Good morning, everyone. Good morning. So, how was last night? Yes? Good? You all enjoyed it? That's great. Not so loud, no. We will have to tell Nina as well to not be too loud. First of all, we have a few housekeeping news things. I want to remind you to not steal the food from the other group. So there's a buffet on that side of the building. Don't go there. We have our own here. There's enough food for everyone. Second thing is pay attention to the talks. First of all, because we ask you to rate them, and more important, when you pass by, you can see I have chocolate, and that's a prize for the quiz that we're preparing for you. So take a look at the slides. Listen to what the presenters are saying, because there's something from each and every presentation. So if you miss many of them, you won't be able to win the prizes. We have chocolate, we have licorice, and we have a lot of fun for the end of the day today. I think I'm done with the housekeeping, so we're 3 minutes ahead of schedule. I'm Italian, we shouldn't be doing this. It's too bad. But we have Nina, who will give us updates about route views. Something new for everyone. Thank you.
Thank you. Hello. And yes, I already had a few requests about not speaking too loud. I'll try. I'll also be slow and mellow, but not too much, because I don't really want you guys to sleep. Because I think I would like you to understand and hear what I have to say. I don't know if this one is correct. Can you hear me? I feel like it's going in and out. No? Okay, good. Excellent. So I'm here once again in a new job. Woohoo! I think that might be an example to follow for people. I think it's my third DKNOG in a new job in a row. So, change is good. Lots of change is very good. I don't know, maybe. Anyways, I am super excited about this project that I'm working on now. It's route views. So first I'm going to do a poll. How many in this room have logged in to a route view server and looked at the routing table? All right, okay. If you want to sleep, it's fine. You can. But on the other hand, maybe you would be interested about what is happening to this project. So let's start with a little background. That's a slide with a lot of text. I'm very happy about the things we have in the back so people can read the slide. But it's a little background because Route Views project is a very old project. It was started in the mid-90s by some researchers at the University of Oregon in the USA. And it has been around since then, and it started collecting BGP tables from networks with the idea of, wouldn't it be nice when you're an internet service operator or an internet network that you could go somewhere else and look at your routes and see what does it look like in the routing table here. So that was sort of the basic idea. And then how about we store the data? Because then we have a snapshot of what the internet looks like now, and we can track and follow how does the internet develop. Because this little thing in the mid-90s, that seems like a good project, and it probably wouldn't take in too much storage because this internet thing is really going to take off. But these guys have been around since then, and so we have the data back to mid-90s and to up to now on constant snapshots every 2 hours of what is collected on the collectors. There's a lot of text on what it is funded by. It used to be its own project on University of Oregon. Some years ago, Dave Meyer and a few other people who were the people behind the project retired, and another project on University of Oregon sort of took over responsibility for this. That's the Network Startup Resource Center, which is a project that's also been around for a very long time. But a project who supports growth of the global internet structure by engineering assistance, technical workshops, and education, in particular in areas that are underserved by education in this technology elsewhere. So emerging markets and focused on university research and education networks. So these guys took the project in and then started hiring some new folks, and one of them is me. So this is the team. This is sort of the core team. We have more people who do like little things as a side. Not everybody on these slides are working full-time on the project. It's actually only 2 of them. The rest of us are doing a little part-time. Some of us between next to our day jobs, some of us sort of as part of consulting gigs. But we have Anton, who is also part of it, who is sitting in this room. We're all over the world. A couple of people in the US, obviously. Some of them are at the University of Oregon. Anton and I are here in Denmark. Philip is in Australia. Trouble is in Hong Kong. So very global team trying to operate and develop this project. So a lot of you already know, but again, it is a tool that allows everyone to look at the BGP tables from particular different vantage points. And this, what can you do for that? Well, reachability, hijacks, bugs, peer visibility, mass withdrawals, whatever the fuck is going on in BGP. So this is what we're looking at, the BGP data. So we're looking at the RIBs, so what does the routing table look like? And we're looking at the updates. What are the messages that are, update messages that are sent? We try to be at every major internet hub in the world. We have not reached that goal, but that's one of them. And then we have multi-hub collectors at the University of Oregon, and that is particularly the ones I remember when I started out as a network engineer, that I would log into and see, oh, we are announcing a new prefix. Yes, it showed up. It's in the global table now. What's also happening to our data is that a lot of the tools that I know that you guys in this room are using every day, like Kaida's ASRank, the BGP reader, Hurricane Electric's BGP tools, Kentic Market Intelligence, Catchpoint, BGPmon, all are pouring our data along with other data sources into their tools and making them great and work. Here's a map, needs to be updated. I forgot to update it in the slides, but you can go to our website and see where do we have collectors. And this can be useful whenever you want to use the tool. So what I want to do now is provide a couple of use cases on how can you use the system. This is very much from my perspective as a peering person. How did I use this? Oh, I shouldn't take this one out of my pocket, sorry. Oh, this is the general size, sorry. Again, repeating myself. The live BMP feed is used to monitor what is going on right now on the internet. And then researchers using the trend, the stored data for trends, what is happening, what has happened over time. Peer negotiation. So how many people in this room work in the peering space? And any of you ever used this tool for you? Yes, Lester. Woohoo! But I'm sure some of you have used some of the tools that is using it. But when you're doing a peering negotiations, for those of you who don't know, you want to know who are the upstreams of the potential peer, who do they already peer with, and who are their customers. Because then you understand the network, and then you know how to put your negotiation in. And you might even know, is this ever going to fly? Are these guys ever going to, accept a peering proposal from me? Or how do I tell my story so they will? So let's have a look at an example. And there we go, a slide with a lot of text that nobody can read. So what we're doing here is sort of like, go log into one of the multi-hop collectors, because this is where we have a lot of full tables. Over time, we're going to have a lot of full tables on the collectors throughout the world as well. But it doesn't really, in this case, it doesn't really matter which one you pick. And then now we're going to do the regex. Now first we're going to look at who are the peers. We have a lot of full tables, so we will have good data on this collector. And then the next step is to play with our regex. Yes, we love regex. And sorry, my did you convert to PDF? No? Oh, sorry. This looked much better on my screen. So let me see if I can walk you through what's going on here. So we have a series of routes, and we have a bunch of AS paths. And then we can go and see, if you look at the last AS number, of course, you see who is originating the prefixes. And that is, we actually asked for all the originated prefixes of the potential peer. If we look at the next AS in the AS path, we see some of them are prepends. Ooh, that indicates that these guys are not super interested in the traffic going that way. So this is likely to their upstreams. So the next AS after the prepends is most likely one of their upstreams. So we get a picture here where we can see, and that's where the arrows go, we can see that this most likely have 3216 as an upstream, or 2914. No, that's actually wrong. I'm looking at the wrong one. It's a Cogent customer we are looking at. And we can also go in and see the tier 1 networks, and most definitely these guys will not be peering with the tier 1 network, so that's also most likely an upstream. So if you want to look at the downstreams, it's probably the best idea to go look at the local collector close to where this peer is, at the IX maybe. And then you go do another regex, which is basically who is behind this AS, and then you have the beautiful list of the ASs behind of the downstreams of the peer. And then, if you really want to find the peers as well, you can take these two sets and then take the rest and say, okay, all of these guys must then be their peers. And there you build a picture of who are they connected to, who are they buying from, who are they selling to, and then you have a good position for your peering negotiation. Questions here? Am I speaking too loud, Jan? Good. So, another use case is just broadly calling it making life easier for your NOG. So, imagine you're in a NOG, and the customers are calling in with a routing issue. Sort of suddenly their traffic is not going where it's supposed to go, or it has a very long delay. Some shit is not working well. And you, as a network engineer, deciding that, oh no, I need to load balance a little bit over my transits. I'm going to deaggregate so I can pull some traffic over where I want it to go. So I've done that. But shit, they're starting complaining, this is not good, what is going on? And then you go into one of the, again, this is a multi-hop So we're looking at what's going on up in the DMZ of the internet on the backbone. And let me go and have a look at the prefixes, my deaggregated prefixes, what is happening to those. And I'm looking at one of them, it's a /20, and I go like, da-da-da, that looks nice. And it has a valid, oh no, it has an invalid RPKI state. Blop. And here is the /19, and this is valid. That's why traffic is going that way, because now on the internet, so many people are filtering for invalids. So my traffic engineering scheme is not working. Uh-oh, we forgot to go create a ROA for the more specific. So let's go fix, and shit will work again. Hopefully, unless we screwed something else up. So what does this tell us? Well, it tells us that the collectors are also providing you with the RPKA states of the prefixes it sees on the collector, just like a router will do in a network that is supporting RPKI. Good. So, how do we get the routes into our system? Well, my title at Route Use is the peering coordinator, because we are just using the good old-fashioned technology. Our servers are peering with networks all over the world. So we have an open peering policy. Oh, no, we don't. We have a peering policy. We used to have an open peering policy and peer with everyone who wanted to. But it doesn't give us what we want anymore. And why is that? Well, I'm going to explain some of the points, but it's basically the operational overhead. So yes, here's the peering policy. I'm not going to go through it, but it basically says, and this is what a peering policy does, who can we say no to? That is what you define in a peering policy. It's not about who your peering strategy is, about who do you want to peer with. But the peering policy is basically, this is when I say no. We've made very small adjustments to the open policy, but the main points are, the main points are why are we doing it, is that there's operational overhead with BTP sessions. There's scale, and there is information that we get in the data. So when we look at all of those three things together, it means that for us, an open policy doesn't make sense anymore. We are wasting a lot of capacity on our collectors, operating sessions that bring us very little interesting information for the project. And which means that we then have to say no to people who want to give us interesting information. So we're trying to balance this out, and this is what we've tried to do in the peering policy. One of the main points is that we're going to say no to hobby networks moving forward. And it's not because we do not like hobby BGP researchers on the network that manage to spin up a network and peer all over the world and see what's happening. We actually love those guys because a lot of us learn from what they're doing. But we are happy to provide them with the data from our system. They can log in, they can download our data, they can see what they're doing through our system. But we will not connect directly to them because a lot of the times they're using gear and software that makes our system unstable. And they're not really providing us with interesting information about what's going on the internet. So, sorry hobby networks, we love you, we support you, we will help you, but we will not peer with you anymore. Another new requirement is we want to see your full view of the internet. Some call this full routes, but not everybody will have full routes in their table because they might take a default from their transit provider and then have a peering network next to that. That works sometimes. But we want to see everything that you get into your table, not your internal. Please do not announce that. But everything you learn from your peers and your transits, please give that to us. And why is that? It's because part of the project is to map out who is connected to who. And if we're just seeing the routes that you're originating and your customers, well, we see that, but we don't see who you connect to. And that means that the data doesn't provide the information about what's going on in the local ecosystems. Because what has happened to the internet over the past 10 years? Well, back, or maybe 15, I don't know, very long. Back in the day, we used to have the tier 1, that was the backbone of the internet. All the major traffic flows would go up from the customers, up through the tier 1, and then back down, and everybody was happy. And then we could create peering. But now we have the majority of the traffic is just staying on the edge, because we know our friends at the CDNs and the cloud, they're all pushing everything to the edge. So now we have a lot of local ecosystems where people are connecting to each other, but that information about those connections is not propagating up into the DMZ. So another reason for being more selective is that we need to go and get the feeds from the edge of the internet in more and more locations. And we want to get the full feed from the edge of the internet so that the local ecosystems are reflected in the data. Because otherwise we do not have a snapshot of the internet. So please, if you want to peer with us, give us all your routes. Finally, we also, of course, has a lot of exceptions. If you're really interesting, I mean, none of these rules will just overrule them, right? So what can make a peering interesting? Well, maybe you have peers and network and connections in some part of the internet that's not very visible in the rest of the data. We would love to see that. Maybe you've come up with something very, very interesting in the way that you interconnect. Maybe you're using new technologies. Or maybe we're just understanding what is going on in a very rapidly growing area of the world. Or maybe something that we don't even know yet. So never give up. We are always ready to talk to people, but we will evaluate every request of connectivity. And I didn't say that, I've got to put that on the side. We will always connect to the route server on an internet exchange. So if you're only able to provide us with your routes, your own routes and your customer code, and you're already on the route server, we're already connected. We love you. Thank you for giving us your data. So, what are we working on? We are working on, basically, we use FRR, which is a BGP daemon. So we're working on researching that, figuring out, upgrading, making sure our collectors is using. We are actually already now, we have all collectors on version 10. We still have one Cisco collector sitting there, so for people who really love iOS, they can log into that one. And then we're trying to move over from sending out a server to asking for a VM, so that we get away from being dependent on hardware, but can sort of be hosted on other people's hardware. We have added new locations. I forgot to update this slide, I'm sorry. We have also added Namex in Rome, and Bucharest came up a couple of days ago, so on Interland in Bucharest. And the next locations that we kind of want to go to is Lagos in Africa, is very much missing on our map. Then we want to change the way that people are using our data, because I'm sorry to say, but today you can log into the collectors using Telnet. So how many people still use Telnet? Oh, okay. How many people do not know what Telnet is? The interesting thing, if you, how many people are lying? Yes. Well, the thing is, like, you actually have to download and install Telnet now when if you're using a MacBook, right? So it's not. Yeah, I should get going. So we're kind of thinking Telnet is going to go away. Another problem we have is that allowing people to log directly into our servers, a lot of people are doing it programmatically. So every 2 minutes, they log into all of our collectors and do show IP BGP. And that is putting a lot of strain on the capacity. So we want to sort of like modernize the access. So we're building an API. We have a beta version ready. Not all collectors are in there. We need a little bit work to do, and then we need to scale it up to have all of the collectors in there. So if you're using our data programmatically, and you're using the real-time data, this is the way to go moving forward. Of course, we have to update all of our internal tools as well to use the new technology, so that's work that's going on as well. We're also creating a looking glass. So for the use case where you want to log in and look at a particular collector and see what's going on there, you'll be using a normal looking glass that most of you are used to use anyway. And then we are also working on scaling and stabilizing our ingest of the BMP data and of the Kafka screen going out, where people can consume the BMP data real time. And then just upgrade and creating tools. So that is what we're spending our time on, and then go out and create more awareness about what's going on, that we're still around. So that's, yes. So again, we were financed by public money in the US, but also a bunch of private sponsors. So we are very grateful for that support. If you want to support us, come talk to me. We would love to find ways that could happen. Another way to support us is, of course, to host a server for us. And again, what we need is a virtual machine and some Ubuntu and access, a little bit of transit, and an iExport. This is the humble ask. And the benefit, again, would be we will help you also provide your customers with a view of what is going on your IXP. We try to not send out more physical hardware unless it is absolutely necessary. Yeah, and here are the specs and the software. And I think with that, I'm going to stop my presentation and ask if there's any questions or comments. And yes, Alexei.
Wait. You have to turn it on.
There we are. Okay, so I'm Alexei from Finland. Can you go to the previous slide? I think it had information about the virtual machine, because what I really wanted to ask first was, are you shipping a virtual machine image, or are you shipping an SSH authorized keys file?
No, we ask for a sort of basic Ubuntu install that we can then use.
Yeah, so you send an authorized key file that we place into the root file, directory, so that they can, you can log in using your existing key.
I'm sorry.
So you can take over the virtual machine.
Yes.
Yeah. Okay. Good.
Yeah.
The other question was, you are planning to start using a looking glass instead of Telnet. Are you writing your own looking glass, or are you using some existing software?
No, I think we're using a predefined. We're using a software already existing, and Anton can tell you what it is.
It's a custom, slightly customized, ordinary looking glass. Well, that was my questions.
Okay, thank you.
Do we have any other questions?
And if you want to know more, I'm here all day. Come ask. And you know who I am and how to get me, so.
So,
Hey,
that was
chocolate!
almost-
Amazing.
Yes, so you get the token of appreciation. Thank you very much. So leave it to me.
Thank you. Thank you
Good.
very much.
So the next presenter actually just went to the microphone, so I asked him to come back now. Where are you hiding? Oh, okay. It's getting a microphone. So it's a topic that's also close to my heart. It's about IPv6 and how we can make use of it to do more peering these days. So please, Alexei.
Thank you. So I am, again, Alexei Suonen from Finland, from Trex. And so the question is, are IPv6 only IXPs coming? We all know that we've run out of IPv4 addresses, which of course has several different definitions. The first definition was that the top level IANA ran out of IPv4 addresses in 2012, and a few months later, the first regional internet registry also ran out of IP addresses. And basically now, if you want IPv4 addresses and you don't have them, you have to go on the open market. There are some exceptions, but you can't get a lot of IP addresses that way. Some years ago, there was a new RFC called, number 5549. It's got a long name, which doesn't really describe very well what it can be used for. This was 2018, but what it basically does is it specifies a way to announce IPv4 routes using IPv6 next hops using BGP. And initially what it was used for was for big operators who want to only run one IP address family in their backbone to tunnel their IPv4 internets and private nets, VPNs, over the IPv6 only backbone. But it can also be used for other purposes, and RFC 8950 just fixes a few things in the old 5549. So it's not much different, but it's a bigger number, so it must be better, right? But basically what this RFC allows network operators to do is free up IPv4 address space for other uses, so that they don't have to go on the market and buy the address space. I've seen some interesting presentations from Facebook or Meta, for example, in recent years, where they've been upgrading first their whole backend and then now their whole backbone into IPv6 only, and then they can start using that address space on their front end. And of course, next they will start work on the front end and the interconnections into other networks. But basically what it boils down to is in normal IPv4 BGP, when routers talk to each other, they first have, on the Ethernet, they have to first make an ARP query to find out the MAC address of the neighboring router. But if you don't have IPv4 on the link, there's nothing you can ARP. So basically, this replaces the ARP query with an IPv6 neighbor solicitation packet, neighbor discovery. So it's a simple concept, but often the implementations have the IPv4 silo and the IPv6 silo pretty separate, so it might be difficult to actually implement in some cases. But there are already a lot of implementations out there, so clearly it can be done. The routers still need an IPv4 address for various sources, uses. I think the most important use is for sending ICMP errors, because your path MTU discovery, your trace route, several things rely on ICMP. And if you don't have any source IPv4 address on the router that you can use to send that, then it becomes problematic. usually the router IDs still are also IPv4 addresses, or at least look like IPv4 addresses. So you typically have one loopback address still on the routers, but it's a /32, so it's not so much waste of space. But my presentation today is about IXPs. So why? We already have tons of IXPs and they already have tons of address space. And RIPE even has a special policy for assigning addresses still for IXPs. 2 years ago, or up until 2 years ago, the default size for IXPs, IPv4 networks, was a /24. So 256 addresses, which is easy to work with for IXPs. So why am I rocking the boat? What's going on? Well, one big reason is that renumbering an IXP is painful. So links in London renumbered from a /22 to /21 a little over 2 years ago. Are there any people here who are connected to links and remember this? Couple very strong hands over there, and a couple of other hands. Yes, so it's always painful. Also, the bigger the subnet becomes that you are renumbering, the pain is multiplied, exponentially. Links has also done this about a decade ago, or the first time they did it was in 1997. So they started as a /24, and then they've renumbered 3 times into what now is a /21. I suppose they have experience in it, but I don't think they still want to do it ever again if they can help it in any way. But of course, the bigger the network, the longer it'll take for them to need to do it again. Desix in Frankfurt has renumbered only once. What they did was clever in that they had done a /24, and then when they renumbered, they chose a new network where they reserved some space next to it. And then after that, they haven't actually renumbered, they've just made the net mask bigger twice. They are effectively renumbering where you don't actually change the numbers, just the net mask. So it's less painful, but it's still not painless. And thanks for Arnold Nipper and Daniel Wagner for giving the dates and details. Nix in Prague has also renumbered once. They skipped 23. They went straight to a /22 in 2011. Thanks to Marian for this date. I couldn't find any information about NetNode ever having renumbered, so I don't think it actually has renumbered. But NetNode is growing, so that day might come. And so on. There are lots of examples that we could use. So the alternative here is that we have the opportunity to never have to renumber again. So when you are nearing the point where you might have to renumber, you might want to weigh the options if you want to really go through the pain of renumbering, or if you want to switch to IPv6 next hops rather than IPv4 next hops. So there's no real shortage to IPv6 next hops at an IXP. So, and these days, most operators already connected to IXPs have an IPv6 address on the subnet, so they don't need to configure new addresses. They just need to reconfigure how they announce their IPv4 address space. So the previously mentioned Nix from Prague is testing it on the Phoenix subnet. So basically, they've got the public Nix where all operators are welcome, and then this Phoenix subnet is a separate sub-IXP where only security vetted ISPs connect. It would be a good and different presentation why they've done that and how it works and so on. But they are using that to test this out. A couple of weeks ago, they had 6 members, 12 sessions, 128 IPv4 prefixes announced in that subnet using this mechanism. Trex, our exchange point in Tampere, is also testing it. We actually haven't told our members that we're testing it, so we don't have any sessions yet there. But we have a new exchange point in Turku, the 3rd biggest city in Finland, where we are testing only having IPv6 addresses. So basically, a couple of years ago, the RIPE address policy for new IXPs was changed so that you no longer get a /24 by default. You only get a /26, so a quarter of a C class, which means that if you are growing slowly, you might have to go through 2 renumbering events before you even get to the full /24. So what if we skip IPv4 completely? So you can still exchange IPv4 traffic, but you don't have an IPv4 address on the IXP peering LAN. The thing is, so when we were setting up this Trex Turku, we already had IPv4 addresses in mind that we'd use there. But then we realized that if we start using them, it might be difficult to ever, get them out of there. So if we are IPv6 only from day 1, then that will raise the hurdle because we already have some members or operators that would like to connect there, but who either know that their devices don't support it yet or don't know if their devices support it yet. So that's the interesting bit. And but I think it's coming along nicely now that there are actual IXPs around the world testing this. So the European Association for IXPs already a couple of years ago started a working group thanks to Arnold Nibel's email on a RIPE mailing list a few years before that to work on this, to adopt best practices for adopting RFC 8950 at IXPs, and also to map out challenges, test interoperability, stuff like that. I am one of the chairmen. Andre Gruneberg from B6 is the other chairman. There are members from many big IXPs and small IXPs. There's also members from software developers. So, for example, Nix is the maker of Bird Routing Daemon. NetDev is the maker of FRR, which was also mentioned in the previous presentation. And we've got a GitHub, the link there, where we are collecting information on how this stuff is configured on different routers, basically what ISPs would need to do to get their router to do this over an exchange point. And we are also trying to collect experiences of, bugs or interoperability issues and stuff like that. We are accepting pull requests, so if you like to contribute, sure. We've got a mailing list and a Mattermost channel also for this working group where we accept external members. So talk to me if you are interested in joining those. And also DKIX is looking for a master's or a bachelor's thesis writer on a topic related to this working group. So if you are a student, here's also one interesting opportunity. This was basically just, an additional slide about some of the topics that I could go more into detail if there's interest. But I guess I could end it here and ask if there are questions specific to this thing. And I see there is.
Job Snyders, just speaking for myself. I want to play devil's advocate a little bit, because the list of challenges is quite long, to the point that I'd be like, this does not sound great at all. And if we look at IPv4 availability, in the RIPE region, just like that, you can get a /26. The average IXP, according to PeeringDB, has 26 members. And you can fit 64 in a /26. So I think most IXPs that start never ever in their lifetime would reach, would deplete the initial assignment that they get. But even if they do, they can still double to the point that, and get to a /24. Now, if you're at the point where you have like 250 members connected to your IX, you're a really big IX, and charging your members a one-off fee of 100 euros to purchase more IPv4 space seems super feasible. So this sounds like a shit ton of work, even though IPv4 is still available and is affordable if you really need it. So what's the business case?
Well, this sounds like a shit ton of work, but the reason we have a working group now is to go through these all the issues. We were actually, when we started, we were surprised at how well things already work. So when there are issues, they don't affect necessarily all platforms, just a few platforms, and we are also in communication with vendors to get them fixed. So if 2-3 years from now somebody wants to really start doing this, then hopefully all the issues will be fixed, or at least they will be better understood. As for starting a new IXP, when you start it, you don't know if you're going to grow or not. So as you say, most don't. But if you do, do you want to? Because this might be a lot of work, but renumbering a 24 into a 23 or 22 is also a lot of work, mostly because a lot of the ISPs don't really have a lot of peering people working for them. Most of those 256 routers don't have a person behind them that will change the address within a year.
I mean, if you start an IXP, the statistics suggest that you're not going to grow beyond a /26, so it's not a problem. If you do, by accident, grow beyond a /26, gee, you're a victim of your success. And again, there is no problem. And renumbering IXPs, is it really that much work? Like, it's a few emails. The people that don't renumber, they don't renumber, whatever.
This is essentially just another way to renumber, except that you've already got the numbers, because you are just starting to use your existing IPv6 addresses for IPv4 space as well. So I'd argue that this is less work, because all you need to do is add an address family with certain configuration settings into your existing BGP IPv6 sessions.
Okay, final question.
Sure.
Your first slide started with, are we going to see IPv4 only IXPs? And I didn't hear a clear answer. What is, how many years?
Well, as I say, our Turku exchange point is such an exchange point.
So globally, you're the first?
I don't know, but I might be. But then again, Asia is a vast area where there's a much bigger shortage of IPv4 addresses, so there might already be things like that over there that we just don't know about.
And there are some people complaining about it. Well, yeah, people. Thank you for the presentation.
Thank you for the questions.
So, another token of appreciation. Thank you very much. Now, to close for our final presentation, because he was ready there, but then I need to take some time then. So it's we're going to see a small investigation into what is a possible attempt at an hijack from Lasse.
Yes.
Yes. Does it work?
Thank you. I put a question mark there at the end because, well, like Alexei, I really don't know. So you be the judge of this. So we've seen this. I want to show you what we've seen. And my question to you is, was this a BGP hijack supposed to happen if we haven't caught it? Or was this just some random event? I don't know, but you be the judge. At least, by the very least, this was an improper use of AS sets. So what actually happened? Our very good cooperation with our IP transit provider caused them to alert us, and thank you, Richard, that someone had created an AS set in the RIPE database referencing our AS number. And anyone can actually do this. So going into IRR Explorer from NLNOG, we saw that these guys, apart from their own AS, they had included our AS in the AS set. And an AS set would be used to sort of make a collection of ASs that has some shared property. And we were thinking, what is the shared property here? So looking into this, these are apparently, well, BGP tools say they are from Russia. And basically, I'm sorry, do I know you? What is all this about? So we looked into that, and well, their country code says they're from Russia. Their address is somewhere in Tehran, Iran. So no, definitely we are not connected to you in any way. Additionally, in their routing policy that they published, they were using this AS set with our AS number included, saying that they would announce this to a tier 1 transit provider. So looking just at the routing registry, which is not BGP, they are saying, yes, we will announce Telia's AS number. No, you will not. So why is this a problem? Because obviously this is just in the RIPE database, and as we know, the RIPE database contains lots of stuff. But what is actually an AS set? Well, an AS set can be used, it's basically just a list of ASs. And you put that list into the RIPE database saying, this is a list of ASs that I want you to know about. And they can be used for anything. It can be ASs that are present at this internet exchange point. It can be ASs that I peer with somehow. Or it can be ASs who the salespeople were out drinking beer with last night. Whatever you want can be an AS set. And I know Lasse wants the last one. But the most common recommended usage of an AS set is to communicate to your IP transit providers. These are the list of ASs that I will be announcing. And so this, I've included an example from Manners, who have a very excellent course on how you do proper filtering on the internet. And a very important part of filtering on the internet is that you filter your customers and what your customers announce to you. All tier 1 operators will do this somehow and with automated tools, and it is all based on AS sets, route objects, etc. in the RIPE database. So this is just an example courseware on how you would properly go around to doing that. But so what is actually the problem with them including our AS in their AS set? Because we are obviously not connected to them, whether they are in Iran or in Russia or anything. Well, this, in my opinion, is a setup to start spoofing our AS set. So it's very easy to just configure a router on your own network and use our AS number. And you can announce this in BGP. And normally, if you just want to spoof and do a normal BGP prefix hijacking, well, you type this IP address prefix that you don't own, and then RPKI will save you because it will not be valid, and then it will be filtered out. But if you also announce using the correct route origin, the origin AS, then suddenly the rower match, but you're not actually the owner of that AS. So other than having a valid rower, then the tier ones would on top of that have the RPSL-based filtering. So filtering based on what is in the IRR databases. And this is usually today what saves you from BGP hijacks that are also spoofing your AS number. But when anyone, and anyone can just put your AS number inside their AS set for any whatever reason that they want, then you basically open yourself up to this, where they say, I will, to my IP transit provider, announce this set of ASs with completely fraudulent entries in it. And well, then we're directly connected to our upstream provider, and that is a tier 1 provider. So yes, now they can spoof our IP addresses, they can spoof our AS number, and suddenly we will have over at the other tier 1 provider an equal AS path length, and they might even be able to attract some of the traffic that should be going to our network. And this is exactly what we don't want to happen, what RPKI was supposed to save us from, but in this type of corner cases, it does not. So what can we do then about fraudulent AS sets and trying to improve this? Well, the best way is ASPA, Autonomous System Provider Authorization. So it's another framework on top of RPKI. We already have ROA, the Route Origin Authorization, where you authorize origination of routes, which only validates the first AS in your AS path. ASPA tries to validate the upstream providers as well. That is currently going through IETF. It's not ready yet, so basically there's no rescue there for you yet. We'll get back to that. So while we're waiting, we need to, well, in Telia we decided we need to monitor what goes on in the internet routing registries regarding our AS numbers and our routes, etc. And we will use various online tools for that, such as IRR Explorer, BGP tools, etc. So ASPA, getting back to that, is exactly specifically targeted against this. This was what I tried to explain. ASPAs will, in short, rather than verify the origin, it will say who are your allowed upstreams, and then the tier 1 provider can check all steps of the AS paths and not just today the origin is validated, and the origin will be valid or invalid. In the future with ASPA, all AS boundaries that are linked in the AS path will be validated individually, and they can be either valid, invalid, or unknown. But, as I said, while we're waiting, what we are doing is monitoring the IRRs. And in BGP tools, for example, basically you look up your AS number and then go to the whois page, and you scroll all the way down beyond the very, very long whois entry, and you will see this AS number is actually a member of the following AS sets. And then you can actually click those AS sets, see where are then those AS sets being referenced. And if there's anything here that you don't recognize, I would encourage you to reach out to the people owning those entries in the database. I've tried to do this with most of the Telia entities that we have, and it's a work. Some people actually respond, most don't. But if you follow this chain of reference with all of the AS sets referencing then AS sets referencing other AS sets, in the end referencing your AS number, then you can sort of have an overview of, well, what are the AS sets that someone could try to pass off to a tier 1 provider or any other IP transit provider and be allowed to spoof your AS number. This is of course tedious work to do manually, so as engineers we want some sort of monitoring system to allow you to do that. But when you do that, you find that there are many AS sets in the database that are questionable, to say the least. For example, I have here IIXP peers, well, and some peering in Düsseldorf, I think, but Telia does not peer with anyone in Düsseldorf. And there's a very long path of recursion here that starts with this AS set mentioned here and goes through a lot of different AS sets that are each referencing each other and then finally coming down to the Telia AS set in the end. Somehow that is being referenced here. And this is the Düsseldorf one. These can just grow to an infinite length in theory, actually. And I'm sure that each and every one of these AS sets are created by someone who has some idea of what they are semantically going to mean. But clearly, something somewhere has gotten lost in the semantics because we are not peering there with this AS number as these guys seems to be suggesting. So I would encourage you to try to use some of these tools, and we use BGP tools, but I'm sure there are others as well. And this would actually, this is a clip from their monitoring page that they provide to us, where this will bring up an alert to our NOC whenever someone actually enters a new AS set in a database somewhere that references us in some recursive form. I would encourage you to do that and come talk to me later if you think this is the first step to a BGP hijack, or if you think that I'm pretty much just overreacting and this is just how the internet works. But so, summing up, I skipped very briefly over ASPA because basically it's not ready yet. But I asked actually Job, who is championing the ASPA efforts in IETF, to just come and quickly tell us, are you ready soon, please? What's the holdup?
So we've been working on this as fast as we can for the last 7 years. ASPA in a standardization organization like IETF is composed of a few components. How do you binary encode this in the RPKI system? So how do we verify the signatures? How do we apply verified information to BGP messages that our routers receive? And how do we get this validated ASPA information into the routers? And it's that last step that we're now in IETF actually working on. My hope is that within a few months the last T's will be crossed and I's will be dotted and that portion is finished. So I'd say we're 95% there, but you know, when you go on vacation and you have your children in the back of your car and they're like, are we there yet? You just make shit up as you go. Next slide, please.
So real soon now is what it says, right?
Any time now. So a few more months. And then, and this is really, really critical, ask your vendors. Because the likes of Nokia are telling me, Joe, nobody's asking for ASPA. I'm like, that's not true, Nokia. And they're like,
I'm asking for it.
Great. But we need more people to do that. Ask Juniper, ask Cisco, ask Nokia, Arista, because that will greatly drive our ability to enable this in the network in the next 2 or 3 years.
You wanted to talk about it?
Last slide. ASPA is not just a theoretical idea that we've been working on for the last 7 years. There actually is usable open source software out there in the form of OpenBHPD, BERT, Routinator, RPKI client. A lot of work has gone into understanding whether ASPA actually works in real environments, such as IX route servers. Yep.
So, real soon now.
Real soon.
And in the meantime, please monitoring what you have. So, monitor what is going on as an operator, as the IETF. Hopefully, it will be soon. Questions, Alexei?
So, Alexis Suonen from Finland. Job wanted to play devil's advocate for my presentation, so I'm returning the favor. This is a simple, sort of stupid question to drive.
The session ends at 40 today, just to let you know.
Yeah. So, can you go back to the ASPA slide, or actually the one before that, where was the spoofing example with the graph of the ASs? This one, yeah. So ASPA will prevent this one, but what if the attacker also spoofs 1299 in between his own AS and spoofed 3301?
You should view ASPA as a means to understand path plausibility. And just like with RPKI route origin validation, the ask towards the community is reject invalid routes. And if the route is not found or valid, then that's not important. ASPA is not BGP-sec, so the AS path to some degree can be forged. But you have to forge plausible paths, and that imposes restrictions on how exactly you can present yourself to the victim of an attack. So, formally speaking, ASPA does nothing against AS spoofing. In practice, it will block a number of situations like these just because the subset of plausible paths that can be spoofed is of course smaller than the number of paths that can be spoofed in general without ASPA constraining what would be plausible or not.
I would say, as an operator, 10 or 15 years ago, IETF came with BGP-sec, and it was perfect, except it was undeployable. So now we have the RPKI setup. We have ROAS that covers maybe 70 or 75% of use cases, and then we have ASPA that covers another maybe 20%. So no, this is not perfect, but if we keep building on top of this RPKI, I think we can sort of stepwise or authorize more and more of the AS path, which will be a lot more helpful than having a perfect setup that no one can deploy.
As to your open question, whether whether you think this is a prelude to an attack or not, I think it is a definite maybe. We've already seen attacks like this in Canada and Korea years ago. So, and we know this is the modus operandi that, for example, Russians use on, well, all battlefields.
We've seen with RPKI.
Can you introduce yourself?
Hi, I'm Julia from Netherlands. We've seen with RPKI, if you make it really hard to hijack the BGP sessions, they'll go for something softer and easier, like the simple password you used for your RIPE account. If we start rolling this out, do we risk just moving the attack vector and the attack surface to something further down the line that perhaps isn't as secured as we think it is?
Yes, definitely.
And my
And if
next
so,
talk is
what
about
should I be
this
attacking?
topic.
Yes, so the answer to your question is yes. If you put a stronger lock on your front door, yes, they will absolutely try to find a window they can break in through, and then you need to then secure your windows. So you just need to keep adding more and more security, because you know better than anyone, security is never perfect.
The S in networking is for security.
Yes.
So we're already almost 5 minutes over. So thank you, Lasse.
Thank you.
We have a break now. It's going to be 25 minutes, so we'll be back at 11:30. One recommendation: our buffet is here, not on the other side. So our food.
Fint.
So I was just commenting that everyone is so quiet. And we still have a minute to go, basically. But everyone is ready to start, so let's start then.
Let's start. Yeah.
Okay. So we have Joachim.
Yes, Joachim. Yeah.
Joachim. He will talk to us about egress peering engineering.
Correct.
And so we'll learn how to do more effective peering.
Yes.
There you go. So the floor is yours.
Cool. Thank you. And thank you everyone for having me here. So I will spend half an hour on talking a bit about egress peering engineering. So there will be no DKNOG without a Cisco guy talking about segment routing. So I will do that as well. But I will try to keep it not too much into the protocols, not too much into the technology and so on. I want to talk more about the use cases. I want to talk a little bit about how SR is being deployed and how you can actually use it in your infrastructure. So egress peering engineering. So why do we actually do that and why do we need that? I would say a lot of things has over the years changed in the way we do our infrastructure, the way we will build the internet. So as we all know, BGP is like, really old, back from the 80s. And the way BGP can create and do the peerings not really is sufficient to what we want to obtain. What we see is that the traffic is moving closer to the user, further out into the metro networks. It's a lot about the metro edge compute. I think many of you have heard about metro edge compute. The CDNs, they're moving further out in the network. And what we actually see is more than 80% of all the traffic we have on the internet is video. All that video is being generated somewhere. It's being generated, and a lot of it is coming from the CDNs, from the caches, and from the OTT players, right? Netflix, YouTube, and all of those guys. So normally or if you look a little back in the time, we had all these content providers. You reach those guys over the internet. So, but the demand on the traffic, the demand of how to be able to deliver this traffic has changed. So we see all these direct peerings we have with the content providers, direct peerings with the caches in the infrastructure. So all these changes into the infrastructure is changing also the way we need to build our network. So I think it's S&P, what they call Global Market Intelligence. They are saying that by 2020, 62% of all data will be computed at the edge. So that means we need to be able to have more traffic into the edge, and we need to be able to steer traffic to and from the edge. So I think most of you agree if we run SP networks that that this is what we are seeing, right? So we need to be able to steer our traffic much, much better. And we need to be able to do more peering engineering. And actually what we're seeing is we get a lot of weird requirements these days. People want to do all kinds of funky traffic engineering. People want to do things like disjointness. They want to do a latency-based routing. They maybe even want to do carbon routing, MACsec encrypted routing, whatever. All kinds of new engineering and optimizations are being put into the network as different requirements. So what we are going to focus on today is how to do this on the egress traffic. So you can do all kinds of engineering on the ingress traffic, you could do all kinds of engineering on the egress traffic. And what we want to do, focus on today is the egress traffic, how to do that. And what we want to obtain is we want to be able to live up to all these KPIs we have. We want to be able to utilize the network much better than we can do today. And we want to drive down the cost, basically. So I guess most SPs has different kinds of peering points, different upstream providers, direct peerings, all of that, right? And you want to be able to completely be in control on how you deliver that traffic based on your KPIs and metrics. So that's what we want to address. And what we live with today is this really old protocol called BGP, right? The two napkin protocol, which we all call it, was like baked back, I think it was from 1989 or something. And it's, I would say, a little bit hard to manipulate and steer traffic just using BGP. We have these BGP path selection criteria that's been there for ages, and they don't really fulfill all the requirements we have to be able to manipulate our traffic. So if you look at the BGP path criteria, you can do quite a little actually. You can do things like local preference, and if people want to play with the METs, you can do that as well, right? But it's quite hard. But you can still do some tricks to do things like hot cold potato routing, but it's fairly limited actually. So what if you want to route your traffic with different behaviors depending on what specific PE you are and what specific prefix you want to receive to reach? Latency, load on the links. Might be that you have a temporary congestion on your upstream, or direct peering, and you actually want to steer parts of your traffic to another egress point to reach the same prefix. It might be temporarily, just during a temporary congestion, right? Could also be like disjointness. We see things like banking industries. They say, yeah, we have two paths. We want to make sure that we always send this traffic from this data center out this egress peer, this upstream provider, and we want to make sure that you always send this peering link. We want to use this upstream provider. It's quite hard actually to obtain that with the BGP instruments that we have today. Yeah, and especially things like load sharing, also quite hard to do with BGP, if you really want to look into that. And we want to also better control the traffic to and from our CDNs, which are consuming a lot of the traffic, right? So how do we do that? We do that with what we call egress peer engineering. If we look back at the the RFCs and the standardization forums, it's actually quite old. The concept was introduced back in 2014, where it was announced in, I would say, a session was DKNOG, I think, yeah. And then it became RFC in 2021. So I would say this is something that I would assume that all vendors are supporting today. So it's not like a Cisco specific thing, even though it's based on SR. And we are leveraging some concepts of the RFC 8402, which is generic segment routing standardization. We're using something which we call BGP peering segments. So yeah, before I go into all these details about BGP peering segments, I would really like to know by a raise of hands how many of you guys are actually running segment routing in your network, or about to run it, or do it somehow in a lab or something. So there is quite some. I know there is actually more than the hands I see. So so what we do here with SR is fundamentally we don't want to change anything on our BGP network design when we want to implement EPE. EPE functionality is something that's required only on the border routers, your ASBRs, as well as the EPE controller. And then when I'm saying controller, people tend to say, ooh, I don't want any controllers to do things, and it's kind of magic, what of this? But the controller function here is quite simple. You need what we call an SRPCE, a path computation element, and the SRPCE is something that you enable on your any XR router, basically can do that. So it's a function you enable on your router, and you are actually ready to go. So the PCE controller is collecting topology information using BGP link state, and then it's actually also having the EPE informations, these BGP peering sets, as we call them, and with those kind of information, the SRPCE is able to push out your policies based on your requirements. So I don't want to do SI in details, but I just want to give you a 1-minute recap of what it is, just to make sure everyone is on the same page, right? So SI is source routing. So what we do is that we push a stack of labels, could be SRv6 or SRMPLS. In this example here, I'm running SRMPLS. So we push a stack of labels to the header, to the ingress on the ingress router, to the IP packet to actually do source routing and steer the traffic based on the labels. You have different label types. In brief, we have the prefix segment and the adjacency segment, where the prefix segment is something that identifies a node, and adjacency segments identifies a specific interface. And by imposing the label stack, you can fairly easy control your traffic on how you want to steer it through your network. And this is what we use for doing basic SR traffic engineering. And I mean, for those that haven't really enabled SR yet, definitely do it. It's super, super simple. As such, it doesn't impact anything. It's something you turn on your ISIS, and you you configure your prefix sets, and that's basically it. You're up and running, and it's hopefully shouldn't do any impact on your running network, so you can run it just turning it on and start using it. So what we do here with the BGP SR peering segments is we are adding 3 new types of sets. We call it the peer node set, peer adjacency set, and the peer set set. That's the only 3 things you need to remember. And those 3 sets we actually use to override the default forwarding behavior we have in BGP. So we want to overcome the limitations of what we are doing with the BGP best path selection algorithms. So the peer node set is always allocated. It's done dynamically. When you configure a BGP peer and eBGP peer, you allocate a BGP node set. And then if you have multiple interfaces links to that peer, let's say you're doing like an eBGP multi-hop session, you have multiple links, then you also allocate an adjacency link on a per link basis. So these peer node set means go to this specific peer, allows traffic to go out multiple interfaces towards this specific peer. The adjacency set, you can actually use that to steer the traffic on a specific link towards your peer. And then the last one is the peer set, where you can actually combine to have a multiple links or peers defined by a peer set. So with the combination of those three SR SID types, you can do a lot of really cool traffic engineering. So as an example here, we have a reference topology. We have AS1, which is you. We are peering with AS4 and 5. One could be a upstream transit provider, one could be a local peer, whatever, and then to reach a prefix in AS6. So traditionally, we can't really do much. We can do like local preference and so on, but the BGP best path has chosen to send all the traffic out via router number 2 here, and all traffic will go through AS4. You might even have a congested link, so on. You'll start dropping packets. You can't do anything, right? You have to go manually and try to somehow overrule this, and it's really, really hard. Because you have a link through AS5 you could also use, but how will you do that? You're just dropping packets, right? You need to be able to steer some parts of the traffic to avoid dropping on that link. Might also be that the link to AS5 is maybe cheaper, better desired for some reason. In this example here, we have, we want to, I think I'm actually going to this one. Yeah, sorry. So the requirement here, we have enabled a SR. Very, very simple, router ISIs. We have a prefix SID allocated, so we have SR running in AS1. So you can see we have the prefix SID with 16,003, which means if we want to send traffic to router 3, we just push that label 16,003 and it will go to that, right? You can see how that looks like here. If you do a trace route, you can see the labels being pushed and yeah, just fundamental segment routing. So what we now want to do is we want to enable this egress peering. The way you do it is it's quite simple. Underneath the neighbor, you just turn on egress engineering. Egress engineering will then start to allocate labels on those neighbors. So you will have the, you can see here we have the peer node SID, label 30,024, 30,035. And the example here, we also have multiple links between 2 and 5, but we have on those specific links, we also allocate the labels. So what can we do now? Now we are setting up the controller, or whatever we call it, is just the SRPCE. It's an instance you turn on in XR. The EP controller here will then receive those labels, those SR labels, and we'll be able to use that for creating a policy you can push out. If you look at that controller, BGP link state, show BGP link state, you will actually see traditional BGP information here, where you will see AS number, you will see your local and remote node AS numbers, and what you will also see is that you are allocating this peer SID, 30,025, towards your neighbor on router 5. So, really good. What can I now use this for? Say, okay, as we saw before, the BGP default behavior is to route from router 1 to router 2 and then to AS4. But there is this guy in AS6, this Mr. Important Network Engineer. He has a host address, 61106/32. He knows that if going from router 1 to router 3 and then router 5, I get lower latency, or it's just a preferred path for him. So what we want to do is that we want to select that egress border router, and then we want to send it out that specific interface. That's really hard today. I mean, if you didn't have this capabilities, then how would you do that? You need to do really, really crafty source-based routing and stuff like that, right? So what we do here is we create a route policy. We set a next hop, we set the label, local preference, and that's something we are defining on the EP controller, on the PCE. So we are making this route policy. What we then do is we advertise this information to the ingress router. We do that with BGP labeled unicast, this example. It could be PSEP, It could be netconf, basically. You can do that different ways. In this example, we are using BGP plus label to actually get that policy pushed out. And what we then do here, if you go to router 1, we have the policy, want to send the traffic. He's then pushing 2 labels to the stack. The first one, 60,003, which is with the prefix SID to go to router 3. And then he's also pushing that label 30,035 to actually send it out that specific interface. Which means now that when you're on router 1, your traffic to that specific prefix 6116 will go out that egress interface. That's smart. So I hope you get it. So this is kind of the theoretical introduction. Now I want to talk a little bit more about some more use cases. What we can also do with EPEs, we can combine this with traditional traffic engineering. So we can combine it with things like link utilization, traffic loss, latency, whatever. So it's not just about the egress interface and the EPE and the BGP peering sets. We can also combine it with other capabilities to do really fancy traffic engineering. If you have congestion somewhere in your network, you can do that. There is also the peer set. So what does this peer set do for us? So in this example here, we are actually having a peer set SID where we are having for the 10.00/24 prefix, we actually receive that from 3 ASs. What we do is we do a peer set SID on all 3 of those to actually do load balancing. So what we can do now here is we can push traffic. We are also combining it in this example with an anycast label. So of 17,001, which is owned by 2 routers. So our ingress traffic will now be perfectly load balanced across your network to your border router that will then also load balance the egress traffic towards all 3 peers. That's quite hard to accomplish without a technology like this. Really cool. What we can also do is we can do what we call weighted ECMP. So normally when we're sending traffic in our infrastructure, we're using like SPF, right? And SPF is choosing a path, and that's the path we're using, and all the traffic goes on the SPF path. But what if we want to actually have this traffic distributed non-unequal, so UCMP. In this example, what we are doing here is we make a policy. That policy is described by a binding set, as we call it, and then we can apply a weight. So in this example, we say, okay, I have my 2 upstream providers, actually 3 here. 2 of them, one of them has a bundle with a lot of capacity. I want to send 80% of the traffic to that upstream provider and 20% to the other upstream provider. And then the ingress router will actually be able to do that. So we haven't had that since EIGRP, I think. So it's quite nice. So we can actually also, with the SRPCE here, we can instruct the PCE. It has like a northbound interface, RESTful interface, where we can have additional, I would say, knowledge about the network as additional northbound controllers to interface to the PCE to actually change a policy while it's still there. So we can change if a link goes down between the on the bundle here between ISPA and router 5. If a link goes down, we can actually change the weight from 80/20 to, for instance, 60/40. So that kind of, let's say, controller functionality is not something that's built into the SRPCE. It's typically something you have on top, some kind of logic. That can be all kind of commercial controllers or something you do yourself or whatever. That's actually an example of that I have in the last slide here. It's a customer of ours that's building a fabric here where they are hosting caches. So it's a content provider, it's an OTT. So what they have done here is they have made their own controller. That controller is getting telemetry information about bandwidth utilization, response times, packet drops. That's going into the controller. And what they have done is those caches you see in the bottom, the 4 caches, they're actually running MPLS. They have an SR stack, which means they can impose any label and steer their traffic. So you can see they have X, Y, and Z. Those are direct peering they have with their partners. And then you have on the WAN interface A and B, they have like a traditional internet upstream, which is for them maybe not preferred, but it's there. And then let's say they are reaching the AAA/24 on X and Y, and you can see 93% of the traffic is going out router Y, and the 50% is only on router X. So they want to control that. And what we do here is we actually sell, you can see you have EPE labels 101 and 102. So you can actually, based on that destination, say, okay, I want to steer more of the traffic here on a specific interface and then out on a specific peering on router X to steer that traffic. So they are doing that directly from the caches. So they are, I would say, going a little bit further than traditionally on your MPLS infrastructure. And you can actually have a lot of information in that controller they're building. Telemetry data, all kinds of, they have IGP topology and so on in that controller. That was my last slide. So I hope you have some really good questions on EPE, and I hope we can have some discussions around implementing SR and how to move forward, because we really want some use cases. I can see Lasse, you have a question?
Yeah, Lasse from Telia. This is all for egress traffic only, and I don't have lots of that, so could you enlighten me? This BGP announcement from your peer, that then is your reachability to where you want to send the traffic. How is that reflected into your segment routing update, so you don't accidentally send this traffic through your segment routing SID to a peer where the BGP prefix has been withdrawn?
Okay, so I get it. So you feel, so it's to avoid like a disconnect of a prefix. So you actually end up sending, what you're afraid of is you're ending up sending traffic towards an egress interface of something which is not being announced by that specific peer, right?
Are you reinventing IGP?
That's what I'm hearing. Theoretically, you could do that. You could send any traffic to any peer by doing that, right? So for me, it's so when you apply the route policy, you have what we call like a color and an endpoint in the SR policy, and if that policy does not match, you don't receive your BGP announcement, so you don't actually have that route available, then you don't apply that color and end policy, so if you don't announce it, if you don't receive it, you will not be able to tag the traffic, and you will not send it out that egress interface.
Okay, thank you.
Yeah, we can discuss the details if you want afterwards. It's a little bit, I didn't have it here in the slides, so yeah, takes more time to explain. No more questions?
Hi,
Nina.
Nina. Nice presentation about an interesting technology about how to traffic engineer across your network. I got confused about your motivational slide because that one was about video being on the edge, and it doesn't really apply to this use case. The whole point of video being on the edge is that it's not traversing the transit networks, which is where this. So I'm just encouraging you to maybe change your motivational slide, because I think this is. If I was working at a transit network, I would love to play with this technology, but otherwise, I don't really see the use case.
Okay. Yeah, but I would say it depends on whom you are. If you are the content provider, then it makes a lot of sense, as I see it, to avoid, like the last slide, to avoid sending traffic on your transit. You want to send it on your direct peer. And I would say
Yes, and they do that already.
they do that
Yes.
already, but they also have to
The point
steer
is,
it, right?
the video doesn't traverse the backbones, or that is what is being avoided as much as possible. This is a technology to choose the best path across the network, the backbone, but the point is to try and avoid it. That's why. That's my feedback. You can take it or leave it.
Cool. Thank you. Thank you, Nina. Yeah.
Well, I would
Yep.
say we don't have any more questions, so we'll have
Cool.
the chocolate for you.
Oh, thank you.
You get the bigger one. And thank you very much.
Thank you.
So, between us and lunch, we have another presentation. Now, this is a very interesting one. It's an overview of traceroute, or a deep dive into traceroute to understand how the internet works.
I don't think we could say it's a deep dive. We only have half an hour. I would need
There you go.
a few
Yeah.
weeks. A lot of whiteboards.
You can
And
speak
patience.
fast. You can speak fast and make it work.
I'll try then to
So, Rory.
talk fast and not stand in your way for lunch,
Oh, yeah.
hopefully. Oh, yes, thank you. We can't always get what we want. So, perfect, thank you. My name is Rory. I work for a company called Crusoe. Crusoe is in a small niche technology that nobody's heard about called AI. And it has the keywords like NeoCloud. It's a relatively new player in the game. They're building infrastructure. It's an interesting place. To steal Nina's line, this is my third DKNOG in a row, I think, with 3 different jobs. Which starts nicely into my intro. Oh, these are old slides. No, I mean, it's an old deck. Can we change to the newer deck, please? I can talk. Yes. Thank you. The presentation I'm giving today, and this is actually perfect, it's not the presentation I started out writing. And that's not even the start of this story. I've had an unhealthy obsession with traceroute for a very long time, probably 2 decades. The first time I used it, I was like, what is this? And then curiosity, I was like, how does this work? Quick question for the audience, actually. Hands up, who has used traceroute before? Actually, let me ask a better question. Who hasn't used traceroute before? Right, nobody. Okay. Hands up if you have ever worked with a customer and they've sent you a traceroute. Now, keep your hands up if that traceroute contained a smoking gun towards the issue you're debugging. Okay, I'm actually impressed. I thought that would be closer to 0. You're looking at your customers. The point I'm getting to here is traceroute is fantastic. It's misunderstood. It's magic. It's fantastic at generating talks for NOGs. It's generated research papers. It's a wonderful tool. It is ubiquitous. It is everywhere. Everyone has used it. Thank you. It's not... I was joking yesterday saying that there is this trope in movies and TVs where you have these ink blots and you show them in front of somebody and they're like, oh, I see my parents fighting. I'm pretty sure I could print out a bunch of traceroutes and show them to you and you'd be like, peering war. Misprogrammed fib. They're... yeah. So, what I was distracted myself from, I started this talk not as this presentation. I started with a simple linear, this is traceroute, this is how you use it, this is how you read the output, done, linear. But as I started that, I realized there's a story to tell, like from the start. Where did it come from? And then I found it really hard to reason about it because it's not a linear, straightforward story. It's a complex, interdependent story with a tool that evolved as the network evolved. And then I realized that this presentation is actually 3 presentations in a trench coat. So we have network topology, we have traceroute, and we have observability of the network. I did say I have an unhealthy obsession with traceroute. Last year, I spent the year trying to build a basically distributed traceroute as a product. There's a bit more to it than that. I tried to build my own startup, and it was interesting. I learned a lot about traceroute, and I learned a lot about what I didn't know about traceroute. So hopefully I can bring something here today to you. So traceroute appeared in the late 80s. From the README, I can see it's in about 89. I did something unusual. I started reading IETF meeting notes from the 80s, which are absolutely fascinating because some of them look like they're faxes. Bad scan in, but there's hints and there's talk about tools in about 87. So hands up. Who is younger than traceroute? Yep, it's a pretty old tool. Another fascinating thing about the start, the origins, is you could consider it to be luck. So 2 people had just finished implementing raw sockets for ping, and that was the work that was needed to build traceroute. It was built by Von Jacobson. He's an American researcher. I tried to track him down. I believe he is an adjunct professor in UCLA, but I couldn't quite find him. This first showed up in BSD 4.3 Reno. Thanks to Theo Lerad for pointing me in that direction. You can find the code online. It's pretty straightforward. It's about 300 or 400 lines of C. And what surprised me is that that version, that algorithm that was encapsulated in the C, is very similar to what we use today. So like I said, it was a suggestion to Von Jacobson, and he had previously a similar tool called TCP trace, which I couldn't find the source for, but I understood this was more about tracking down nodes on the network than actual traceroute. So the first version, like I said, it's quite similar to what we have today. You have UDP probes. The key, the magic, is that we use the TTL field in the header to figure out what path, what router is on the path. There's an interesting aside here where the TTL field originally was supposed to be seconds in the network. But because of competing implementations at the time on routing and IP software stacks, the version that used TTL as the hop count won. So we almost got a very different type of trace route. Because if that was based on seconds in the network, I think the buffer bloat people would be very unhappy. And I think that we wouldn't have all day long to run trace routes. This is back in 89. Networks were a different beast then. And this comes back to the fact that this is 3 presentations in a trench coat. And it is not a linear discussion, so we're going to be jumping forward and back a little bit. So as best as I can reason, late 80s, early 90s, the internet was growing rapidly. In some of the IETF notes, I noticed that NetNode was connected with an entire 56 kilobits. Immense speed. I'm sorry, NordUnet, not NetNode. we didn't have many load balancing, multipathing on the internet at the time. It wasn't really needed. The first version, surprisingly, also had timing of the probes, but it is a little bit rough. It'll measure to about millisecond latency, which is fine. And this is another interesting aside. The first version was actually using ICMP probes instead of UDP probes. However, and stop me if you've never heard this before, there were some router control planes that weren't very powerful and weren't very happy with ICMP as the probe, so they moved to UDP, I believe, the night before they released the first version. This is from the current OpenBSD man page, who has preserved some historical facts in there, and it's actually an interesting read if anyone wants to take the time. Because it also contains the first traceroute I could find, which is interesting because it is larger than I expected it to be. 18 hops. I believe the missing hops along the way are due to a bug in BSD, I want to say, where the devices were forwarding, taking a packet in with TTL1, decrementing to 0 and forwarding it, and it got dropped on the next hop. Oops. I'm so glad that all of these types of bugs no longer exist today. So, I mentioned the probes. Back in the 80s and 90s, and even early 2000s, the internet was hierarchical, but load balancing wasn't front and center. I'll make a lot of assumptions today around all of my examples. They're going to be based on roughly ECMP, closed topology. That will be a 3-stage. And we will be doing and working on hashing, load sharing for layer 2, layer 3, and layer 4 tuples. So by that, I mean the IP, source test IP, source test port, and protocol will be used to make a forwarding decision. So I'll run through the algorithm for the first traceroute. What it did, so we send 3 packets out sequentially. We pick a random destination port and a random source port. Usually, you start at about 33434. You generate a packet that has a TTL of 1, destination port, source port set, protocol UDP, source test IP, and you send it into the network. Now, we can see that the source is the left top router. It generates 3 probes, 1, 2, 3. What happens is first packet goes on the wire, TTL gets decremented to 0, gets sent to the control plane. It generates an ICMP message, TTL expired, encapsulates the ingress packet into the ICMP message, puts it back in the wire, sends it back to the source. So now at the source, we know that this router has originated an ICMP TTL expired. We know the first hop in terms of TTL away from us. We go for the second probe. We increment the dest port by the TTL, by the probes sent. So we'll see the incrementing destination port, and that will be the only entropy in the packet that changes except for checksums. And because of hashing, we'll pick a different route and we'll send it out. And that way we can figure out roughly how many routers are a TTL away. We can measure the time, as I said, about millisecond resolution. So we can get a rough idea of the return time. However, one of the things that is missing is the wrong way to describe it, but one of the things I wish traceroute could tell me is the return path. However, this is not possible for a lot of reasons, sadly. Anyway, so we only send 3 probes by default. You'll notice that we haven't got full coverage of what is 1 TTL away. It is worth noting, and it should keep in mind that what we're actually doing is not discovering all the hops. we're taking a statistically significant guess at how many hops are a TTL away. That sounds a bit difficult to reason and a bit abstract, but traceroute won't tell you all the nodes on a given path. At the time, and the internet was relatively flat in terms of load sharing, this wasn't really a problem. However, in the last decade, we'll see that this is starting to become more common. Anyway, we move on to the next TTL, which is 2 away. You can see that we do the same algorithm. We're incrementing the destination port and changing the TTL for this run. And what's worth noting here is that you'll see the lighter color is the previous paths we've traversed. However, our first probe here, packet number 1 on the diagram, it's taking a different path. But we will not record that router in the traceroute because it's not going to generate an ICMP for us. And same thing again. We go on to the next, we run the algorithm again, and we'll see that we're actually missing a whole bunch of information because of how hashing works. And we finish. And this brings me on to hashing, which comes under money names. I'm saying hashing. I probably should say load sharing, load balancing. It's the same thing here. So I mentioned back in the early days, the internet didn't really use hashing too much. There is balancing of traffic across prefixes with BGP policies. We just heard from the previous presenter about egress traffic engineering. So there's a lot of work getting done in the space, even today, for load sharing and balancing. When we come to having multiple paths on a router, we need to figure out a way to balance traffic and make a decision about what traffic should go to what path. So we can take the first real and easy way to do this would be per packet load balancing. And in the audience, could you put your hand up if you've ever had success in deploying per packet load balancing without breaking any applications? So we don't use the per packet anymore, thankfully. So we've evolved this a bit. We do flow hashing mostly today. Flow hashing is a shorthand for we use the layer 2 information, the layer 3 information, source test IP, and layer 4 and protocol. However, you can also use source IP, test IP, source prefix, test prefix. It's up to the operator to decide, but each of these different strategies will have a different effect on how traceroute is run. I think it would be exhaustive to cover all of the use cases, and like I said, I'm standing between you and lunch, and I don't want you to hate me even more, so we won't cover an exhaustive list here. It's good to keep it in mind. And it's also a good segue into both observability and router architecture that I will try not to get into today. But if you see me around later, please ask me and I will talk for way too long about specifics here. It is a fascinating topic to figure out how does traffic get through a router, into the control plane, out of the control plane, what happens inside of this box of magic. It's one of my favorite games, which is where did the packet go? I mentioned we use different hashing strategies, and you noticed previously from the first traceroute, it was actually supposed to be ICMP probes. I'm glad it isn't actually, because of this simple example I used, which is the output from MTR. What you see here on the left is ICMP. It's run 5 times. That's it. That's just the only modification I've made to the command. And then for UDP, same thing, except I asked it to use UDP probes instead of ICMP. So we suddenly have extra hops appearing. It's well worth keeping in mind that there is ICMP as a probe type is very difficult to enumerate load balancing and multipath. I would suggest and urge to not use ICMP in this method, in this way for trace routes. Try to go towards UDP or TCP. So, as I was saying at the start, this is an interdependent talk. When I started this, I thought it would be easy, and it is not. So, the timeline of traceroute is interesting, but is also dependent on how networks evolved. And as I was doing this, it was nice to see the way the internet has evolved over 30-something years of this history, and how traceroute has changed slowly over time. We can see the first one appeared in '87. What we call DKNOG traceroute appeared about 90s. I mentioned MTR previously. That appeared actually way before I expected, in 1997. It had a little rebranding in 1998 from MATS traceroute to traceroute. TCP traceroute appeared 2001. And what I find interesting is Paris showed up in 2006. I will talk a little bit more about Paris, just a little bit. But it is really the first time we see a master's thesis done on traceroute with publications behind it. And there's a very specific goal that they had in Paris. And then about a decade later, Dublin came along. These two last names are, if you couldn't guess, they're from the cities that the version was born in, invented in. And I thought we had nothing from 2015 to now. Max kindly nerd-sniped me just before I got on stage. There is more. So I'm going to move a little bit quicker now, sorry, because we have 10 minutes left. Quickly, DKNOG, roughly the same. Does parallel probing, adds AS lookup, which is really useful. Tightens up time resolution. MTR, I hope that you're all familiar with MTR. If you're not, I suggest you become familiar with MTR. By default, it uses ICMP probes. Not really a fan of, but what MTR does is actually quite smart. It runs your traceroute algorithm, but for every hop, it then runs a ping. So it can reason about packet loss because it keeps running like a liveliness detector. Or if you're unlucky like me, it runs a test on your control plane policing. So by that, I mean you're going to see loss where there's no real loss, which customers love and completely understand. And surprise, TCP traceroute, would you guess, uses TCP. This is interesting because it does not change the entropy. And you know what they say, entropy is not what it used to be. Which means that when you run it, successful runs should go through the same path if you have a multipath network. Paris. So Paris is a paper, it is published, you can read it. This is 20 years roughly after traceroute came along. There is a bunch of topologies on that are now commonplace that it's hard to reason about from a default traceroute. Diamonds and loops, basically. And Paris was an attempt to figure out of the protocols, which fields in the headers are used for entropy. By entropy, I mean hashing decision. And they use those and manipulate just those fields and figure out what's my topology. And Dublin was more focused on NAT and ECMP environments. I will not talk about NAT today. I think we're all hopefully in the mindset that IPv6 will fix NAT. And NAT 6.6 doesn't exist. And it can't hurt you. Dublin is interesting. It builds on Paris work, but it brings two other things to the table. It has a library that's reusable, and it has a common exchange for traceroute information. And I believe the author of Dublin and Paris are talking about making this more of a thing where you can easily import traceroute into your app or build it in a library and have a common exchange format. I reached out to Antonio, the author of Dublin Traceroute, for some comments on it, and he pointed me in this direction. A quick mention about OpenBSD recently revved their traceroute. No algorithm change, but it runs much faster. It does all the probing in parallel, so you can actually resolve a full traceroute in seconds versus tens of seconds. We'll do a quick trip down memory lane, and then I'll let you to lunch. Networks have changed, thankfully. Although I have noticed that we keep trying to reinvent ATM. We have OAM in Metro E. We have packet fragmenting in Ultra E. It seems like it'll never go away. We had a lot of software forwarding back then. Networking duct tape, so tunnels, they've come along since the 90s. They changed the way traceroute works. We'll cover it quickly. Today, unless you're doing DPTK, which is kernel bypass for faster routing, anything that's touching and forwarding a packet is probably going to do it in an ASIC. Overlays are everywhere. Like, I don't know if there's SPs out there that don't run MPLS, which is, again, ATM in a trench coat. VXLAN is now in the data center everywhere. GRE sticks everything together. We have IPv6, which is notable for a reason I will touch on in a moment. We have a more distributed internet. Things have changed rapidly. Here's a rough guess, and after talking to some people, this is how I'm kind of thinking of the timeline. IPv6 has been around longer than you think. And it's a shame its adoption isn't bigger. For a reason, again, I'll point in a second. We saw MPLS, late 90s was the first deployment. ASICs all over the place around the same time. We started to hash better around the Brocade Trident launch, Broadcom Trident, sorry, where we had a larger fib in a switch for cheaper and we could do routing. And that was when we also saw Clo appearing in the data center. And you can see, if you remember back to my previous slide about the origin of traceroute, you'll see the two of them have a good mapping, that the networks change and there's a reaction in traceroute. I will just skip to the end, sorry, and give you a summary and then let you ask me some awkward questions. This first line is directly from the first opening line in the Paris paper. Fatten Jacobson traceroute is one of the most widely used measurement tools, and that is indisputable. There is a loose relationship between how the network's changed and how traceroute has changed. And as I alluded to earlier, reading traceroute can be like reading tea leaves. Some people are good at it. Some people get depressed and angry about it. They're all normal reactions. Something I'd like you to ponder is the fact that Windows traceroute is the most historically correct version of traceroute, and be horrified at that idea. An area I would love to work more on, and I tried to figure out and reason last year, is the asymmetry of the internet. Forward and reverse paths are never the same. It would be interesting actually to get the data from root views and figure out, can you make a reasonable guess about a symmetrical reverse path to a forward path? But like I said, ask me and I'll talk about this for ages. We currently can't really measure reverse paths. It is sad. And with that, I will just get to my queue questions, if you have any. I will thank you for your time. Sorry for eating into your lunch. No pun intended.
Okay, let's start from the queue.
Aaron Glenn, just a dude. As a longtime fan of Traceroute, I was wondering if you had any opinions on why it's been so ossified and not been developed over time.
Yes, I have opinions.
Was there one or two you wanted to share very quickly?
I'm not sure. Like I said, this journey of making this presentation, it led me down a different path I didn't expect. I was somewhat surprised that there is not more research in traceroute. I'm also surprised that there's not more efforts to get reverse path into the mix. I know that DKNOG15 was working on an internet draft to do better timing, so you could actually reason the reverse path. That is still internet draft. Ben Carter Coxwright, I apologize if I butchered his name, the BGP Tools guy. He has a fantastic article called Splitting the Ping, and that actually reasons about the latency on a reverse path. But from ping's perspective, it wouldn't be hard to lift that into traceroute. To answer, I'm actually not sure. It would be wonderful to get more research and development in this area, but I'm biased as well, so. Does that answer your question?
I think if I can add something, I think it's people see it and think, "Ah, it's a simple tool. Why would I spend time working on it?" And
Henrik Kramselund from Security. I just want to ask if you know about RIPE Atlas probes.
Yes.
Because they are awesome for doing debugging, and
yes.
You can like automate so much and do it from the command line even.
Yes, thank you for bringing it up, as well as the NL-NOG ring. You know what I'm talking about. Yeah, yeah. Ask Job.
And there's also global ping as well. That's similar to RIPE Atlas. Yep.
Any other questions? Then one closing comment from me, if there isn't. Go ahead. We are actually hiring in Iceland if anyone wants to work in a data center. With, like I said, this new niche technology, AI. It's a pity that Joff isn't here from yesterday's morning's talk, because this data center is 80 megawatts of geothermal. Thank you.
Well, thank you.
And thank you.
So you go.
Thank you very much.
Thank you. Thank you. Thank you. So it's lunchtime. We start again in an hour at 1:30, and it's good we finished perfectly on time.
Welcome back. Welcome back from lunch. All right. We hope you had a good lunch, and we are on the home stretch, the last part of the day now. We have one coffee break left in between. But yeah, we have Julia to talk about what happens when hackers are inside the building.
Mayhem.
So please give a round of applause.
Hi, to just continue the trend that Nina started. This is my second time talking at DKNOG, but my first time with a live audience, which should tell you exactly which year I was here. So, I work for a pen testing company, penetration testing. Worked for them since 2020. It's an interesting use case, so I thought I'd just give you a bit of a chat about what we do, because our network is weird. Right, so just in case anyone doesn't know, what is penetration testing? We basically come along and try and break into your network, building, website, app, whatever you're willing to pay us to do. We do various different things. Some of our tests are what we call black box, where we don't know what you're doing, what's in there. Some of them are white box tests, where we have access to all of your code as well. We do something called red teaming, where as a group we will pretend to be an adversary. I all speak with a Russian accent for a week. And we will try and penetrate your organization, usually with a defined goal. We have a lot of customers, which because of the nature of our organization, I can tell you none of them. What I can say is they include banks, they include hospitals, health insurance, government departments, and everything also down to tiny little sort of, specialist web stores that sell tennis products and things like that. But the other customer that we have is ourselves. Because we are a penetration testing company, when I set something up and I want a pen test, it's really easy to get. So whereas you lot have to negotiate funding and suppliers and all of that, I can just send an email across the office. So, where do we start? Unfortunately, while we'd like everyone to be nice and fluffy and kind and generous, the reality is we all have a target on our back. Every single person. The question is, how big is your target and who is looking at it? And for that, we come down to an exercise called threat modeling. Who here has partaken in a threat modeling exercise? Okay, both of you, keep your hand up if you've redone that exercise since January the 20th. I like you. And you. Yeah. The world has changed in the last 2 months. We have to take that into account. So in our organization, this is the other thing. Threat modeling is not a short exercise. It's not something you do on a Thursday afternoon over a coffee with a few of you and get it home and done with. For us, it was a 2-hour session, once a month for a year. We had the CISO, myself, and a cross-section of the most senior pen testers. And we went through. And then we do it again, regularly. And you have to update it because threats change. Technology changes. When it comes to threat modeling, the thing to remember, it's all about risk. And as many a drunk person has said whilst laying on the floor outside the pub, it was a calculated risk. Turns out I suck at maths. Humans are awful at calculating and understanding risk. Absolutely dreadful. There are things that people are incredibly terrified of, flying. And as a result, for example, of the 9/11 attacks, people didn't fly. And as a result of that, more people died in car crashes driving up and down the east coast of the US rather than flying in the year after. Because people don't understand risk. And there are hundreds of examples I could use, and every time I do the talk, I'll probably pick a different one. So, it is also worth noting that whilst I'm talking about this from companies, organizations' perspective, you also need to consider that we as individuals can benefit from threat modeling. There is a very good talk done by Danny. She did it at WICON, which is the Women in Cybersecurity Community Association annual event in the Netherlands. It's available on YouTube. I highly recommend it. So, a lot of organizations, the first thing they do is they go, well, we should install some antivirus software, some malware detection. And because the technology landscape is the dumpster fire it is, they go to Microsoft Defender. Who here uses Microsoft Defender? That's quite a few of you. So it's very good at detecting malware. For what it's designed for, I have minimal complaints. The problem is we actually have malware that we use intentionally. We have hacking tools that we use intentionally. We installed it on one of my colleagues' laptops. He had worked for us for 2 years at that point. We set it up, and we made the mistake that every time there is an alert in Defender, I get an email. I denial of serviced my inbox with 327 alerts in the space of 5 minutes. I run Outlook in a Windows VM. That machine was just unusable for the rest of the day. Just all of the pop-ups coming up. There is a way around this. Defender has the option to exclude a directory. And so we ask all of our pen testers to have a directory for their toys that they put them in. We also ask, use virtual machines. Virtual machines are great for compartmentalizing things. Though, we discovered an interesting bug last week. If you're using VMware Fusion, it shares a paste buffer. So if you copy an SQL injection, or cross-site scripting or something, inside your VM, Defender outside the VM will flag. This confused the hell out of us. Took us a while to work out what was going on. So what's my next slide? Right. If you study networking in a formal environment, or do a Cisco course, you will be told that there are 7 layers to the network, the standard OSI model. Then you get told, but in reality we do TCP IP, so there's only 5 layers. But the reality is there are 10. So aside from the 7 that you all know, layer 8 is the meat sack sat at the computer. This has always been a problem. There's an acronym that's been in the jargon file since before some of you were born, which is PEBCAC. Problem exists between keyboard and chair. Layer 9 is the meat sack's boss. They are the ones that come along and go, well, I was playing golf with a supplier the other day, and I've signed a contract and we're using their software. Cool, what was their security audit like? A what? And then number 10, the one that we've all become incredibly aware of recently, government. Whether that is a case of, say, some tin pot little island moored off Europe that says, hey, Apple, we want a backdoor into all of your storage systems. Or whether it's some civilized country in the Nordics who want to break end-to-end encryption. Sweden. There are lots of problems that we have that exist in layer 10. And unfortunately, whilst I would suggest that there are solutions, wikipedia.org/guillotine.html, generally speaking, we don't have much control there. But for the rest of the layers, we do. And I'm going to stick on this slide for a while. So when I said our network is weird, I really meant it. We have roughly 46 users. And for that number of users, I have 7 or 8, depending on how you count them, physical firewall router boxes. Because we do compartmentalization in a big way. And it starts right down on layer 1. Physically separating networks. And you know, you think, you're going to be asking, bloody hell, she's paranoid. No, the question is not, am I paranoid? The question is, am I paranoid enough? So we start off with, does this need to be connected to a network? We have one system which lives in a box. Inside that box has 2 locks on it. That box then has 2 tamper-evident seals on it, and it's kept in a safe that only 4 people can access. Those 2 locks, 2 people have the key to one lock, and 2 people have the key to the other lock. That is our root certificate authority. If you host your own CA, that is the level of paranoia you need. You have to have it offline. So, moving up into layer 2. Who here uses 802.1x authentication for their networks? Thank you to 5 of you. I'm going to say no. So authenticating the actual physical layer is incredibly useful. So if you look up on the ceiling, you'll see that there are 2, at least from my perspective, 2 Unify Wi-Fi access points. Those are incredibly common at most organizations. They do no authentication. If I can get physical access to your building, obviously it doesn't work on the ceiling here because I'm not Dutch, I can't reach that tool. However, if you go to the toilet and look up, you'll notice that there is one that is much easier to reach. Somewhere dark, out the way, not many people watching, and there's no camera. If you can get physical access to that, you can plug in a Raspberry Pi. With a Raspberry Pi, it can dial out. Congratulations, you've backdoored the network. If you use things like 802.1x, you can authenticate who is on your network. People don't do it because people aren't paranoid enough. The other thing that a lot of people do with that is you've got your office, you've got Ethernet ports all the way around there. They all go back to the patch panel. They're all plugged into the router. Not the router, to the switch. Why? Yes, it makes it easier that someone can just plug in. But if you don't have that cable there, you can't have somebody come in and plug something in the office where it's relatively easy to get to. If they have to ask IT to get off their arse, walk down the other end of the building and actually patch the cable in, it's a lot harder an attack vector. Going up into the IP layer, one of the problems we have is a lot of our customers are behind content delivery networks. And what they're supposed to do is tell the customer, these are the IP addresses that we are testing from. Please can you whitelist them so that we don't flag any of your security alerts? That's what's supposed to happen. And it does, about 98% of the time. But the problem we were running into is one of the big content delivery networks is used by the company that we buy the groceries and the coffee for the office with. And every so often, a customer would screw up. And the reason we knew this was because we couldn't order lunch, which is a dangerous situation to be in. And the solution was we give each team of about 4 or 5 pen testers a pair of VPNs. One on this server, one on that server, because redundancy. So they go out on a specific IP address. So when we get blocked, we know at least which of the 3 or 4 it was that screwed up. Oh, that's slide here, haven't I? So those are the sorts of paranoia things. The other one, who here actually uses your out-of-band network, IPMI, all of that sort of stuff on your switches and stuff? How many of you stick that behind a completely firewalled network? Okay, the fact that that wasn't the same set on both sides of the questions, that's a problem. Because IPMI, UPS, PDUs, they don't get updates to the firmware. You know, a PDU can have a life cycle of 10 or 20 years because it's not doing much, it's just switching power occasionally, and most of the time it doesn't even switch anything. And so it sits there, and it's running HTTP, it's running IPv4, and in a lot of organizations it's probably still got the default password, which on APC is APC, APC, and that's on a network. And suddenly you're starting to get access to that. And once you've got access to one thing, you can move sideways. And it's terrifying when you hear what some of my colleagues will do with that. So we have a meeting once a month where they basically show off their latest hacks, anonymized, obviously, because we can't tell the world what we're doing particularly much. But it's nice to be able to show off to your friends. And we did one, I think it was a red teaming attack on a hospital. And we had such comprehensive control. We set up a phishing site. We got a few people to sign up through it, give us their passwords. We got in, and it was like people in admin. And once we got on their machine, we could sniff the network. We could find some NTLM hashes that were going past. We grabbed them. We've got our own password cracking tool, which is a power nightmare when it's turned on. Don't be behind the rack when they power it up, it scares you. And from that, we were able to get full access right into the domain controller. And I was sat there, just as an admin, watching this talk. It's completely anonymized. And I had to walk up to my colleague and say, I'm being treated by this hospital and this hospital. Please tell me they weren't our customers. Fortunately, it wasn't. But that is the sort of example of the control that we get. Now, for an organization, most of your problems are at layer 8. Because we can do all of these things with compartmentalization. We can do stuff with firewalls. We can do stuff with authentication and all of that sort of stuff. But if you click that link that somebody just sent you and you type in your username and password, all of the security is bypassed. Now, because we're a security company, we are a big target. And you've heard of phishing, but there is a variant of phishing called spear phishing, which is a directed attack. That's not just the, hi, you're a customer of such and such bank, your account's been blocked, please log in, that we all get. No, these are the dedicated, hi, I am CEO of company. Could you please contact me on WhatsApp? That's one of the common ones. Between updating a new member of staff, updating their LinkedIn, and getting their first spear phishing email, how long do we think that takes? Anyone want to guess? Not quite that bad. Any other guesses? We've got 45 seconds. Price is Right rules. 10 minutes. Oh, wow, you lot are actually more paranoid than me on this one. It's about 2 hours. Between 2 to 3 hours, we will get a spear phishing attack. To the point that on the first day, before they get their laptop, we have to brief new members of staff. The new pen testers are okay with that. But we have people that are less technical, sales, HR, office management, sysadmins. And so we have to brief them about what we're doing. How are we doing for time? So the thing to remember, as XKCD sums it up, we think of all of the effort of hacking into buildings and picking locks and all of that stuff. The easiest way to get access to a system is just ask for it. Email someone. Oh yeah, I've forgotten my password. Can you reset it? How do you authenticate that email? How do you authenticate that message on Slack? It used to be that we could trust a phone call. You could trust a Teams call. But the reality is that is no longer possible. With deep fakes, we saw that with a bank in Hong Kong, that it is possible for someone to make a video or a phone call that you just cannot tell is fake. So we have to do it in person. I really hope my colleague in Algeria does not forget his password, because that's going to be expensive. That is actually my colleague's laptop. Now, he has assured me that that is not actually his password. He did that just to wind me up. Yes.
It's a honeypot.
But I've used this photo. So all of the photos in Less Credited are ones that I've taken. I use this just to illustrate the point. There are a lot of people who, you're laughing at the idea of writing passwords down. The reality is, though, actually, we do need to write passwords down because we've got so many of them. But we call it password managers. But you also need to remember the master password. And people other than you might need it. in the management safe in my office, there is a tamper-evident bag, and it is labelled only to be opened in the event of Julia's death. And it has the password to the backup of my laptop. Writing passwords down is not necessarily a bad thing. I'm going to skip over the key management one. So, I talked about getting physical access. We all think about the nice lock that you've got on the server room door, and all of that sort of stuff. I have a whole archive of videos from my colleagues of where they've walked in half the time to an unlocked server room or an unlocked network cabinet. That one's a really common one. But even where it is locked, you would be amazed at how simple it is to bypass them. So some of you may have noticed that I'm walking around with lockpicks on my earrings. That's partly because it's a really easy way of getting them into a building. But the reality is, if you are down to the idea of picking a lock, you're not the lock-picking lawyer. You're not going to get in. And whilst most of my colleagues can do it, it's not an attack you need to do. Because the reality is, even though you've spent 200, 300 euros on a fancy lock, this is a sheet of plastic that my colleague carries around with them. AliExpress, €2.50 for a pack of 3, delivered in about 10 days. And it just detects, you can push it through the lock and you get access. And the great thing about this is it doesn't set off metal detectors, so you can take it on flights. My other colleague prefers this. Again, €4 from AliExpress. And it's more effective, it's easier to use. The problem is it sets off the metal detector, and people start asking questions. But the plastic, oh, if you get stopped, why are you carrying this around? Oh, it was litter, I picked it up. It is amazing how easy it is to get physical access. And once you have physical access, all bets are off. Who here actually locks their server room? Okay, there are a lot of you that do not have your hand up there. Far too many of you. So, when it comes to the software stack, I have quite a rant about Docker, but unfortunately, I only have 7 minutes left, not 7 hours. But one of the problems that a lot of us have, we learned this from SolarWinds, is we do not know what is installed on our machines. If I was to point to a machine that you have deployed and ask, what version of OpenSSL are you running? People will look at you blankly. This came up with, this is a request from one of my colleagues. He had managed to get access to a restricted bash shell on a machine. And restricted bash, you don't have mkdir, you don't have touch, you can't really write anything. You've got a lot of restrictions in what you can do. But he realized that because of the way this system was set up, if he could create a directory and he could put a file in it, that file would be executed automatically. So he came to me as the local Linux nerd. How can I create a directory when I don't have any of the standard tools? Anyone want to guess what technique you can use for this? No, it's wget. Believe it or not, wget, the tool that we use to download stuff onto our machines, can create a directory if you tell it to. And people just leave them installed. They've got rid of all of the other things, but they forget about having a simple tool like wget around that bypasses their security. This is something you need to think about in your threat models. I know that on my router, I have TCP dump, I have nmap. These are tools that if someone gets access to that machine, they can use to get round my network. But I have to balance the risk between, do I want to have to install these every time, potentially when I don't have a network connection to do it with, versus what is the risk of somebody getting in and abusing that connection. The other thing you have to remember with all of this is you have to act in on the basis that it is not a question of if you will be hacked, it is a question of when. Hands up if you have a disaster recovery plan. Okay, maybe 10% of you. Hands up if you've tested it. Thank you, both of you. Hands up if your test was anything other than a disaster. A friend of mine used to work for a company whose name might be at the start of the alphabet. And they run into the issue of how do you cold start the organization if, for some reason, everything gets switched off or if everything is hacked? Hands up if you've got a backup. Hands up if you've tested your backup. Hands up if you have an off-site backup. Offline backup? Okay, so that's less than a dozen. Remember, blessed are the paranoid, for they test their backups. My first job as a spotty little 17-year-old, as an apprentice, one of it was literally to change the backup tapes. And one day we got a restore request. And we went to last night's backup and it was blank. So they said, can you go to the local fire safe and get this week, all of this week's out? And they were blank. So they sent me down to the loading dock to where there was another fire safe where we kept the last year's worth. And they were blank. Because we'd done the backup and it was saying, backup is done. But we'd never verified that it was actually doing it. You need to have a disaster recovery plan. You need to know what that plan is. You need to test it. You need to make sure you've got an offline backup so that if you are hit with ransomware, you can restore. There are a number of ransomware attacks where they wait. They waited 3 months before they actually activated. And the result was that whilst the organization had 3 months of backups, they had 3 months backup of the encrypted ransomware files. They couldn't do the restore. So, assume that it's going to happen and plan accordingly. I wanted a slightly different quote to the usual one that I use about being paranoid enough. Yeah, it's hard not to be paranoid when you see all of the situations where people screw up and you think, could have told you so on that one. Facebook dumped all of their GPG routes and didn't have access to their out-of-band network because it was connected to the same network as everything else. We're all sat here thinking, just have an out-of-band network. They all had it all together, and so they couldn't get into their building because their building was connected to the same system that their network was on. So, we've got 2-3 minutes. Any questions?
Thank you for the presentation. I don't have a question as such, but I do have a piece of trivia that you can take along with you for your further presentations. In Denmark, I'm Mirza. I'm from the Union for IT Professionals in Denmark. In Denmark, we have a different error code for PEPCAC, and it's called error 40, because the error exists 40 centimeters from the screen.
Nice.
I'm Thomas. I don't work in networking. I play with computers for fun. And I think, do you think it's accurate that you've been using the word paranoid because it sounds like you have an accurate perception of risk rather than an inaccurate perception of risk?
You're not paranoid if they really are out to get you.
Right. Right.
Yeah. Paranoid is just an optimist with experience.
Yeah. Any last questions? Give you a big round of applause.
Thank you.
Chocolates. And now we will have Mr. Job Snijders ranting about something, I'm assuming.
No.
So please give Job a big round of applause.
All right, let's get some slides up. I will warm up the crowd with what I consider one of the best jokes, and it applies to this presentation. Why do you never see elephants hiding in a tree?
Ah, exactly. All right, we're going to talk about hiding. In this presentation, I'm going to go through some risks I perceive around RPKI, measures I, with my RPKI client project, have taken so far to mitigate those risks, some solutions I have in mind, and then we can get to some Q&A. So, threats to RPKI, and I'm not going to talk about political threats or centralization, or what if I don't pay my bill, or what if I don't use two-factor authentication on my RIPE account. I'm going to talk about hacking the RPKI validators themselves. If you look at the ecosystem, you have academic people that have a paper quota and that are working very hard to contribute to their own quota rather than the state of science. There is three-letter agencies, I assume, who are taking a close look at RPKI because it can impact international connectivity. I myself joined this crowd, and there's of course operators that push buttons until it works, and they could be the attackers themselves by accident. It's too bad Tom Strix is not here. Tom, if you're watching. So why can RPKI validators even be hacked? What is the scenario that leads up to this? Now, keep in mind, and I've anonymized, the ISPs here. Every validator, every validator is primed with a number of trust anchor locators, and those contain URLs to a certificate that contains a signature, and if the signature checks out, you follow the URLs in that certificate, and then so on and on. So every validator contacts the RIPE repository, assuming the validator loaded the RIPE TAL, and it fetches data, processes it, and continues. Now, you can delegate authority for resources, for IP addresses, for ASNs, for many IP addresses, for single IP addresses. So in this schematic overview, I instructed RIPE NCC to delegate authority for my resources to my publication point. And this means that after the validators contacted RIPE's repository and slurped in all the data, they'll find a reference to my repository and connect to my repository, and I can feed them any data I want. So this is sort of where the attack vector starts to show up. With DNS, you only ask questions about stuff you're interested in, right? So it's a pool protocol. With RPKI, you slurp in everything, and you hope that there's something of value somewhere hidden in what you slurped in. In terms of delegations, this is from earlier this morning at 8 a.m. as I was struggling to generate this image, and Alan was waiting for me to submit these slides. Good coordination. But there's many delegations in the ecosystem already today. This is not a fake thing. It is a key part of how RPKI works, and it's used for great purposes such as experimentation and development of new RPKI standards like ASPA. But there's also academic researchers that are sort of looking how they can disrupt the ecosystem around RPKI and then publish papers and meet their quota. I'm super impressed by the scientific people in this regard. The key thing here is we install RPKI validators in order to reject RPKI invalid routes in BGP to increase the security and reliability of the network. But those validators, in and of themselves, bring new risks to the table that are less well understood. Repositories can serve poison pills, so to speak. If I know that somebody's validator is going to connect to me, I can feed them anything I want. And people are researching this. So for instance, the Fort validator some time ago had a buffer overflow in a specific function. and you could craft a syntactically invalid ROA, but you could feed it to the validator, and the Fort validator would choke on this ROA, and you could use that as a launchpad towards system compromise. Of course, Fort is not the only one. The Rust project Routinator has also seen a number of security issues over the years, not buffer overflows in this instance, but like a logic error that could cause downstream effects in the sense that it could cause the RTR sessions to go down, which means that the routers are now running without RPKI data, which means that you increase your likeliness of successfully doing hijacks. A lot of research has gone into this over the last few years, and this is a slide I stole from other people. And basically, all projects have had security incidents, except, of course, mine. Fingers crossed. No, that's not entirely true. They only listed problems they knew about, and I have found issues in my software and fixed them, so they didn't count for this particular overview. So in short, all validators at some point in time will have issues. We can worry about crashing the validator, which would flip the route from valid to not found because ROA information is missing if the validator is gone. You know, that's nasty, but it's also sort of, you know, the fallback. Like when you turn off the validators, your network just operates continuous operation without RPKI. What's trickier is if the operating system itself can be compromised with the validator as entry point. Like that is super nasty stuff because from that moment on, it's like you have an unauthorized IBGP session in your network and people can insert things they should not be inserting. My concern at some time is that if people perceive RPKI to be more of a hassle, more of a risk than the reward that it gives us and helps stabilize internet operations, that they turn off RPKI, and that would really set back the clock on routing security. So I think this topic of how do we secure validators, or how do we approach the topic of validator insecurity is very important. So for the sake of what I'm going to present after this slide, let's assume every year, every validator suffers some vulnerability. Now, if an attacker knows which validators impact which ISPs, it gives them leverage, because from that moment on, they can attack specific validator instances to disrupt a specific ISP and then help bootstrap a BGP hijack. And a fun artifact is that on the internet there currently are a few thousand validators. There's a few tens of repositories. There is no guarantee that there's any-to-any connectivity between the validators and the repositories. It is possible that, you know, between your validator and the RIPE repository, there's one line card on the path that is just broken and your packets are not getting through. Why this matters, we'll get to later. So, as I mentioned before, every validator connects to every repository, and repositories can refer to other repositories. So I can just look at my web server's access log and I can see the IP addresses of all the validators connecting to me. Now I can feed all these validators different ROAS, and then I can go to like route views and see which ISPs have are acting on which ROAS. So, you know, if I give everybody a ROA that invalidates my BGP announcement, except for one IP address, I give them a different ROA that actually validates my announcement, I can start to triangulate where validators are located and how they impact the network. So, what can be done about this? For example, in RPKI client, we have implemented a number of strategies to minimize risk. So one of the approaches is ASN1 and X509 and DER parsing is done using well-known cryptographic libraries like OpenSSL and LibreSSL. And this is fantastic because there's hundreds of research entities looking at those libraries, trying to find issues in the processing of certificates. So we benefit from the collective fuzzing and review that happens in that space. Another cool thing to do is sandboxing on either file system level or even system call level. The validator starts, it reads a little bit of configuration, and then it tells the kernel, from now on in the program flow, I only need access to this one directory that is my temporary cache scribbling directory, and I don't need access to anything else on the system. And then when the kernel detects, oh, you're trying to access a file like /etc/password, it kills the process because that violates a signal the process gave earlier on that they only needed access to the cache directory. So sandboxing is super cool, and it runs on both BSD and Linux, and this is very helpful. Randomization in a lot of the control paths. So when you resolve a repository and look for other work to do, like what is the list of ROAS I need to process, or are there certificates pointing to other repositories? If you walk that every time in the same order, an attacker could maybe figure out what the order is of a specific implementation, and if it's like alphabetical order, they could, for instance, try and generate a key pair where the public key component starts with an advantage if there's alphabetical ordering. So instead, we every time there is a list of things, like a to-do list, and the order of things is not relevant and doesn't have semantic meaning in the RPKI. In RPKI client, the list is randomized and then handed over for further processing. So this, even if an attacker would be successful, they'd only be successful once out of every n iterations. Then there is a concept called boxing things in. So there's a time limit on how long repositories can take to download or synchronize, how large the files can be, how large the repositories can be, how long the certificate change can be. Like there's all these aspects where potential DOS factors exist, and you put a limit on it so that a single repository cannot disrupt the entire program. Cool. Another approach we've taken is called separation of privileges. The program starts, and it starts a number of sub-processes, and each sub-process is confined to, with, for instance, unview or landlock or pledge, to specific privileges. So, for instance, there's a process that sets up the TLS connection, but that same process does not do XML parsing. And this is cool because the process that sets up the TLS connection is a part of a sub-process that has the privilege to establish network connections. And if an attacker finds an issue in the XML parser, they can try and insert the bad thing to trick the XML parser, but the XML parser doesn't have access to the network, nor does it have access to the disk. So even if there's an exploit in that particular segment of the code, it's sandboxed to a point where the attacker cannot use it to bootstrap and get a reverse shell or whatnot going on. RPKI client is the only one that uses separation of privileges across multiple sub-processes. But what else is there to do? Now, I think, and this may be a little bit radical, that we should look at hiding validators. Because I think we have pushed the envelope on how secure we can make the program itself. And I think data has shown we've gotten very, very far, and the principles applied are strong. It's similar principles that are used in for instance, OpenSSH. But what if it's not enough? What if somebody finds something and they still continue down the path of attacking a specific ISP by attacking that specific validator? So I would argue in the RPKI protocols, the only thing that matters is that data goes from the publication point to the validator, but it's not relevant for the working of the protocol that the publication point knows the source IP address of the validator. And what I mentioned before, if you know the IP addresses of a validator and you know which validators at which IP addresses operate for a certain ISP, then that ISP is at a disadvantage. So conceptually, internet-wide multicast would have been great for the RPKI use case, but we don't have internet-wide multicast, so we can't use that. Strength is in numbers. What I have been studying the last few weeks is putting validators behind Tor and using the Tor network to exit into the real internet and using those validators behind Tor to feed, for instance, the default source of stay RTR. Now, a second thing that needs to be researched. As I mentioned, the publication point doesn't need to know the source IP addresses of the things that fetch data from the publication point. We can put in a caching layer that is inside the Tor network, caches that use FQDNs that end with .onion, so that if you want to fetch data from, say, RIPE's repository, instead of connecting directly via the internet to RIPE's repository, use Tor and you exit with via an exit node, and your IP address every time you make a connection is going to be different. But a second layer of obfuscation in this space is that instead of connecting to RIPE's repository via Tor, is that you connect to a forward proxy hosted inside Tor, so that you're never even making a connection to the RIPE repository using Tor. And this works because RRDP, the RPKI distribution protocol, is a highly cacheable protocol. It's static files that are pre-generated, so it's perfect to put that data into forward proxies and not even hit the origin, which is RIPE in this instance. So how good or bad is this? I have set up a number of validators. Some of them directly connect to the repositories and operate just like apt-get install RPKI clients, and some of them are running behind Tor. And the graph that you see is the number of validated ROA payloads over time. So the vertical axis is the number of payloads that is retrieved out of the system, and the horizontal axis is as time goes by. And what you can see is that the 5 instances are super close to each other with their outputs. And this is because there's minute differences, because all of them run at slightly different timers. So one might start at like the top of the hour, and the next instance might end up running 30 seconds past the top of the hour, and so on. So there's minute differences based on timing, and that's okay. It's unavoidable, but it's fine. And this is why the line is not a singular line that is the exact same at all times. But it does show that the 5 instances, whether they're using Tor or not, very closely approximate each other. In other words, they are delivering the same results as with and without Tor. So that's very good news. The other thing to note here is that the Tor network generally doesn't appear to be as reliable as direct connections in the general case. But conversely, there are instances that are in harder to reach parts of the world that have issues connecting to some repositories on the other side of the world. And using Tor actually helps those nodes, because instead of always trying the same direct path where there might be some kind of issue, if you use Tor, every time you try and connect, you use a different path with a different exit node on a different continent or a different ISP. So it's a bit weird, but using Tor increases the number of connection failures per day. And let's assume that per day you're doing, say, 6 times 24 synchronization attempts. But if there is brokenness in a sort of steady state, then Tor may help resolve the steady state brokenness. So Tor is a nice randomizing factor in whether you can reach or not reach a certain repository, but as it serves as an overlay with different exit points every time you connect, you increase your chances of being able to successfully synchronize with the repositories. So it's interesting. Now, going forward, what do we do with this knowledge, Job? I feel wiser, but it's not actionable. I think next up on my to-do list is figuring out if we can generalize the mechanism of forward proxies for the RPKI. There's benefits in using forward proxies because it would reduce the burden placed on RPKI repositories. Why this matters, for instance, for the last 8 days, the Japanese NIR, JPNIC, has had scaling issues with their RPKI repository servers. They're overloaded. Had there been the concept of forward proxies, it may have taken off load to the point that whatever setup they have continues to work rather than what we see now. Can those forward proxies be put inside Tor so that the requests never even leave the Tor environment? This is an area of experimentation, and I need to spend some time on that. Other open questions are what to do with transport failovers. Validators these days will try RRDP, which is a TLS HTTP-based synchronization protocol. If that doesn't work, TLS certificate expired, or XML encoding error, or connection timeout, whatever, it will try rsync. And rsync is super cool because it works really well in low bandwidth environments. So using both approaches, one after the other in a preferential order, seems to me to increase reliability of the overall system. But how that exactly interacts with Tor, it needs to be studied a little bit more. Another thing I think needs to happen is the Tor software, a Tor implementation should be put inside RPKI validators so that operators install the software like they've always done, and out of the box this connection type becomes available rather than setting up a Tor daemon with a SOX to HTTP proxy and then the validator process using the proxy. The hoops I had to jump through to produce a proof of concept are of sufficient height that I don't think it is feasible to promote this on internet scale. But if we put Tor capabilities inside validators, it becomes a whole different story, and you can just tell people, install the software, or even better, update your software, and you're done. So I hope that that is the direction that we can eventually move to. Now, small request for consideration. I'm going around with my hat. In order to further study this and experiment with it at scale, it is useful to have resources distributed over this planet that can be forward proxies in and outside of Tor and can run validators to see if their measurements align with what other validators in other ISPs and countries are seeing. So if you're a cloud provider and you're like, sure, Job, you can have an account and some VMs, then send me an email and I will be happy to take your offer and use that for research. Now, we are getting to the end of my presentation. I think there is about 5 minutes left. So bring it on. Tomatoes, questions?
No questions?
Everybody is like,
one
yep,
question?
yep. Tor inside validators. That makes perfect sense, Joe. We have no questions. Thank you.
You mentioned using Tor. How do you get around the fact that so many people try to block Tor?
That is a great question. From my observations, the blockage for the well-known list of Tor exit nodes is not present in the RPKI ecosystem. So I have found no issues using Tor exit node IP addresses to synchronize with repositories.
And how much resources and hosting are you looking for? You just want a VM with some disk somewhere, or do you need shitloads of
No.
storage?
This is super modest. I think a few gigs of RAM, 2 cores, and a few gigabytes of disk. That's very helpful. The challenge is more in getting good geographic distribution to really look at this. Like, does it work from all angles? Will it work for everyone, or will this anonymization trick only work for people in Amsterdam? Like, I want good answers on how does it work globally.
Hello, I'm Nicholas from Nordlys. My question here is, we're looking into this, and this seems like we're building security by obscurity on top of RPKI. And is it not reasoning to say is that we're reaching the limits of what we can use RPKI on? You mentioned a new solution earlier today, but is it not where we need to rethink what we're doing? Because this seems like we're building a lot of obscurity into a solution to try and solve some security issues and make it better, but making it very complex.
Complexity is job security, so I think you raised a good question, but my inspiration actually came from something most of us are using. Like Apple Private Relay is using oblivious HTTPS, that is basically a 2-layer proxying service to obfuscate the source IP addresses of phones. And I thought to myself, like, they must be doing this for some reason. Maybe those reasons could apply to RPKI validators as well. And I will accept that should the outcome of the continued studies in this area indeed prove like, okay, the complexity versus risk mitigation benefits, it's not worth it. Yeah, maybe that's the conclusion. I don't know yet. I am a little bit optimistic, but certainly it cannot. Certainly, implementing Tor inside a validator is complexity, and I think the only way to really figure out like is it worth it is by really trying it.
Sounds good. We will hear in a few DKNOGs, I guess. So sounds good. Thank you.
Was it job or job security?
Yes.
Job security. So Alexis Suonen from Finland. It may be that some of Julia's paranoia is rubbing off on me, but when you said that you'd want to try and set up Squid or other web proxy inside the Tor network, I'm immediately worried that if it's a proxy set up for this purpose, then the potential attacker will know who is setting it up and doesn't need a lot of social engineering to find out where it's set up, and then can just DOS that location and defeat the whole purpose.
Yeah, I think if there were like one proxy, that might be a risk, but I envision a design where there's multiple operated by whoever wants to operate them. Built into the RPKI technology stack already today is a lot of replay detection and mitigation. So even if you connect to a bad proxy, it's absolutely not the end of the world. And this already happens today. Like RIPE-NCC serves out the RPKI content via a few CDNs, and it has happened that like in one region of the world, the Anycasted CDN node was behind compared to the other CDNs. It was still caching something and it could not fetch from the origin the latest version. So in effect, in that region of the world, you see what the validator considers a replay attack, but it's also part of normal operations. So validators already today are prepared to connect to trashy locations and deal with whatever garbage they find there. So I think having forward proxies doesn't really change the dynamics much, but I hear it. Yeah.
Another worry is that if you are planning to have a fallback on direct connections if Tor fails, then if somebody wants to target malcontent for your validator, they can just start identifying Tor exits and then block them so that you have to drop back to direct connections and then you're back to square one.
Yeah, and I think the only mitigation is either rsync through Tor, which you mentioned can be blocked, or forward proxies in Tor so that even if the outbound connection fails, there is a way to get to fresh data. But yeah, these are things that need to be fully understood.
Thanks.
Thank you.
Last question.
Theo from Interlink, what do you think are the odds that especially enterprises will adopt RPKI through Tor as somewhat, in some areas, debatable system in their operational kind of business?
If I do this my way, operators would never know that Tor is in the validator. Right. It's this is why I want to explore putting it in the validator, because at that point you just install it like you always did, and instead of direct connections, it's doing some other trickery. But writing the how-tos like install the Tor daemon, do this, do this, do this, that's not going to work. So it needs to be a fully integrated, out-of-the-box experience where, with or without Tor, it's the exact same workflow. And I think only in that way we'd get people on board, because they're using default settings, and default settings could be that Tor is used.
Yeah, I agree with that. I was just thinking about the question that it introduces a somewhat political component to PKI, especially when you look at like government organizations, enterprises, and so on.
Yeah, maybe. Let's not call it Tor, we'll call it onion routing, and then everybody's like, sure, that sounds fine. All right, thank you all for your time.
Please give you a big round of applause. There you go.
2 of them.
2 small ones. It's 1 big.
Really? All right, yeah. 1 for each hand. Thank you.
Please welcome Paul to the stage. He will be talking about PeeringDB. Please give him a round of applause. Thank you.
I have to move this so I can actually see the screen. Hi, I'm Paul. I'm a volunteer for PeeringDB. Now, for those of you who don't know what PeeringDB is, it's a public directory of networks on the internet, the exchanges they connect to, and the data centers they are located in. I'm going to give some info about the organization, about new features which we introduced last year, and new features that are upcoming and why you should be prepared for some of those. PeeringDB is run by volunteers, either organized in committees or board members. Now these board members rotate, and 3 positions come up this year. If you want to vote on those, please join the member list. And all this can of course be found on the website as well. One of the things we did last year is automatically remove ASNs from the database once they are reclaimed by the RIRs, which happens a lot. One of the other improvements was on search. We currently have 2 search versions which you can switch between on the website. Please try it out. They give different results, and do let us know if you find any problems with those. PeeringDB Pi is a tool which you can run on any Linux computer. It lets you download the whole database and do queries locally, which takes the strain off from our servers, and therefore we need, well, less of them. And remember that PeeringDB is paid by our sponsors. It's not a commercial organization that makes a profit from all of this. We containerized our software, and I hope the containers won't fall off when we drag our anchors. And nowadays you can export all the data, the things like data center locations with KML into Google Earth and other tools. You can find us on LinkedIn, Facebook. We have a blog with news. Now we get to the important part. Two-factor authentication for the website will be made mandatory very soon. You can already turn it on. You just need an authenticator app like the ones from Google or from Microsoft or many others to do that. And we've got several other ways to secure this as well and make sure that you can get in if something goes wrong. And for the API, we're also going to introduce passkey, API keys to protect it. So you might need to change your software if you have software that queries the database. And last of all, I'd like to thank all our sponsors. We got quite a few new ones as well, and this makes us run this whole system. Any questions? No? Thank you.
Well, that was quick. So we have a bit more coffee break. We will be meeting back for the last part of the session at 15:15. Enjoy. Welcome back into the room. I hope you enjoyed the cake and coffee. We are in the final stretch. One more presentation and then a quiz where you can win awesome prizes if you paid attention. So, but before that, we will have Theo talking about tips for IP transit customers. Please give him a big hand.
Ooh. Thanks. Thanks, perfect. Hello everyone, my name is Theo and I'm standing between you, the quiz and the weekend, so I think it's the worst spot on the agenda, so I'm trying to keep the 350 slides short and don't make this longer than needed. This is not my presentation actually, it's a presentation of a colleague that is unfortunately sick today and I try to cover this as good as I can. Very quick intro, I'm an ex-engineer, now co-founder of Interlink. We're doing fully automated, sustainable IP, layer 2 and other stuff, and try to do this from engineers for engineers. And we have quite some experience with building, running, automating, and selling IP transit. And we learned a couple of things about the last 1.5, 2 years. And that's some lessons learned that I want to share. This is not a presentation about RPKI or ASPA or anything else. I think it's BGP, IR related, and it's definitely not a presentation about what we aim for as the gold standard. It's lessons learned and should kind of give a few insights in what would make provisioning IP transit a bit easier for everybody. And it's a lot of small fixes that we discovered everybody can just make in a couple of minutes, seconds, that just help us on the way to what Job is advocating for, which is perfect routing security at some point. So when we provision 900 something services, not all of them were live customers, some of them were test services, but a decent percentage of those provision services failed while provisioning. And why did they fail? Because we have it automated, so we rely on good data to do so. So whenever the data is shit, it fails. And that is something we spend a lot of resources on to just improve, talk to customers, educate, and that's what I'm going to kind of have a look at today. As I said, it's IRR-based right now. That is what most operators, most IXs, a lot of networks use. This isn't the future, but as I said, there's a lot of kind of small stuff that we can do. So quick recap, we will have a look at how prefix filter generation works for most networks as of today. We will have a look at the data sources that are being used, what sources to use in your network, what trusted sources to use, and in the end, a bit of a excursus into how make the data readable for everybody. So first, when we look at prefix filters and how it's being done, then usually the life of a customer that wants to purchase IP transit or does peering is the customer registers an ASN, in this case this one here, creates an autonom object for that, and that in the next step leads to a route object that has a certain origin set for that network. And then in the third step, usually that customer creates hopefully an AS set and make that ASN that was registered earlier part of that AS set as a member. And then, and this is what we do internally, we build somewhat of a tree. We say, hey, this customer has that AS set, that AS member, and that is the prefix that we're going to retrieve, or that is the prefix that the customer is going to announce to us. And then the funny step comes. The customer goes into our portal, clicks IP transit, blah, 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 and provisions the service and puts in data. And usually that starts by putting in the AS number. And then we are trying to get data from that customer to finally retrieve what prefixes is the customer going to announce to us and make that part of our AS set as well. And that then leads to this hierarchical tree. We have our AS set, customer AS, and customer prefix finally. And yes, V6 here. And then when we use a tool, for example, like BGP Q4, we pull the AS set of the customer, we retrieve the prefix, and that says, hey, this prefix is what we're going to accept. And we'll talk about this in a second, but you see I highlighted the word probably, and that will play a key role in the failure and the success we had with that data. And one of the challenges we also encountered was that with 900 services being provisioned and so on and so forth, the data adds up. It's a lot of customers from different regions, different type of customers, enterprises, ISPs, all across Europe. And that is the next challenge that comes in when you do a lot of transit. So when we look at an AS set and look at the prefixes, and we used IRR3 here, we try to get an idea, again, idea in red, of the total number of prefixes. So for example, AS545, AS inter.link, gives you 6,000 ASNs and roughly 46,000 prefixes that we cover across our customer cone. So the next step is, what data sources should we use to get that data from? And the two things that I mentioned earlier, we use BGPQ4 to probably get all the customer prefixes, and we use IRR3 to get an idea of the number of prefixes. And why do I use probably an idea? Because that's a quite challenging thing. So the problem statement we came across was, first, I need to get your AS set. So the usual source we would look for is PeeringDB. First challenge, not all of you have a PeeringDB record. That's the first thing that we tell customers, please get that fixed, have a record where you put data in that we can even use. Because if the customer goes to a portal, wants to order stuff automatically, puts in the AS number, and there's no PeeringDB record, then that's the first blocker usually that we encounter. And the second step is, where do we get the AS set from if there's no PeeringDB record, or if there is a PeeringDB record which contains data that we cannot read. And also, when we look at the prefix data that we want to gather, we have to look at a lot of IRR databases. That is, I haven't counted them even, but it's dozens of databases. And not all of them are authoritative, not all of them are trusted. So what do we do internally? We run IRRD servers locally. We mirror the IRR databases. We do not mirror all of them, but a certain subset of them. And we query our IRRD service internally. Why that? Because if you run prefix filter updates every now and then, not just nightly, but also if customers are onboarded, you're going to get into scaling issues at some point. And also, it helps us have just all the data in one place, build a redundant setup that we can use to query the data. But then we have customers that created two AS sets. They have one AS set, for example, here with AS Apple. They have it in ArrayDB, and they have it in RIPE. So the question is, which one should we use? We can, of course, ask the customer, but it would be nicer if the customer can somehow automatically tell us if there is a need for two, which one to use. And when we look at this AS Apple thing here, we see that we have an AS set in RIPE that is actually empty. And we have an AS set in RARDB, which it looks like contains the prefixes that Apple plans to announce. Again, which one to use? And there's a couple examples. I think one is listed here. I think, Job, you were involved as well here. When somebody squatted the AS set of Amazon, created one in RIPE that was just dummy or like fake data, and the original one is in RARDB. So potentially you can just pay, I don't know, $500 a year to RARDB and just create your own AS set. There's other databases like AltDB where I think you just have to register, create an AS set, and that's it. So how can we make customers tell us which AS set we should use if there is multiple out there created by the customer, or if there's multiple out there created by the customer and someone trying to hijack or fake or impersonate the customer? And that brings us to the next step. So when you look at this record here, we see that Apple has just said, hey, we have AS Apple. Apple doesn't tell us which IRR source they say is authoritative for their AS set. Google, on the other hand, says, by the notation on the right, guys, please use ArrayDB for generating the prefix list for me. And that is something that is relatively easy to add, because most of you, I guess, have just one AS set in one IRR database. Why not telling us that this is the data to use? And yes, IR is not perfect, but it's just a tiny little thing you can do to at least improve it a little bit. And I think towards the 100% of routing security that people in this room are advocating for, every percentage that we improve that is just simple to do is something that we should do. And then the next thing is, and I pulled some data from, or we pulled some data from PeeringDB here, is that there is no definition on how to define your AS set in PeeringDB. So some use the colon, some use an @ symbol, and we see that the dominant thing is the colon. So what you can do is just easy. Go to PeeringDB. If you have just a single AS set, just add the source to PeeringDB that your AS set is authoritative, or the database that your AS set sits in. So let's have a look at the sources as a next step. So this is one example here where somebody created an AS set. In this case, it was us, but somebody could have created an AS set in a database that has just the same name. So you create an AS set that is asintro.link in the database, and we're going to pull this and then have to decide what data to take from that. So what a couple of RIRs have done is they have enforced hierarchical AS sets in their databases. And Upnick and Ripe are doing it. Lucknick apparently job has forced them magically to do it. I haven't found any other source publicly, but there's at least 3 RIRs that in their databases enforce you to just create an AS set that contains your AS number and then your AS set. And that at least improves, again, routing security a tiny little bit. So if you don't have a hierarchical AS set, please do so and create it in any of the databases. So ideally, we would transition from AS Apple to RADB AS Google to, at some point, RIPE AS5405 asintro.link. That would tell us, please, asintro.link you can find in the RIPE database. That's the authoritative source we say it is. It's beyond or behind AS5405, and that gives additional clarity, but also increases routing security. And also important, that doesn't even require you to make any big changes. It's just a definition of where's your data and what should we use. So please, if you haven't done that yet in RIPE, and if the situation is easy, if you're a PeeringDB administrator, just make that change when possible to make things easy. So the next step is which sources are actually trusted. And IRR, Job and I agreed on this, isn't a trusted system, but there are sources that are less trusted and more trusted. So when you look at the RR databases that have no authentication and you check how many AS sets do you have in PeeringDB for those, AltDB, Level 3, RADB, that you can just pay for or even get it for free, it's quite a bit. It's 500 records that use IR sources that are not considered trusted. So what you can do is you can move your AS set actually in a source that is trusted, and you can add the source into your PeeringDB record, you can make it hierarchical, and that is another step to make it not just easier for us, but again, improve routing security a tiny little bit. So that brings us to the last part of what I think is something that would really help, is formatting. Because when you look at the AS field in PeeringDB, and that's maybe something we should talk to PeeringDB about improving, which we haven't done yet, honestly, is looking at the format of the AS set field. So I have a couple examples, a few slides later, but you will see that there is companies that put a comma in between 2 AS sets, for example. There's companies that put a white space between the 2 AS sets. There's companies who don't even. So there's no formatting rules for this field. And that makes it even harder if you run automation against PeeringDB and you get 50 different formats. That breaks. So what we see, for example, we see, and I haven't anonymized the networks here, but you see there's people that put like a V6 in the end. There's people who have just a 6 in the end. There is even completely different AS sets in there. And there's also companies that put different AS sets for different purposes, like customers and so on in there. So again, when you automate against PeeringDB, which one are you using? So please make it easier for us and everybody else. Just make the data clear and unique. And that goes further on. You can have, like, as you see here, some route servers have different AS sets, for example, per peering LAN, which makes it easier to just pull the EKIX routes for Berlin. Does it even exist anymore? I don't know. But the same goes for peering lines and also different peering lines. Yeah. And the next example that I brought is like sometimes there is aspa at ripe, colon, and even without. So just make that unique that we can read it automatically. Yeah, so quick recap towards the end. First step is create that hierarchical AS set, add a source to your AS set in PeeringDB, please, and also importantly, please talk to a provider or use a peering partner, IX or whatever, that also honors that value. And move your AS set into one of the IRR DBs, and also consolidate your PeeringDB record into one AS set. And I think that's it. Any questions? Everybody would like to get to the quiz?
Not even one? No?
Ah, I knew it. Go on.
Is it on? It is on. Can you go back to the slide with the table of the IRRs and their status on hierarchical naming enforcement? Right. So LACNIC was fixed because right from the get-go, when they first deployed an IRR daemon, which was just a few years ago, they asked me like, hey Joe, what should we do? And I was like, hey, why don't you just right from the start make it proper? And like, yeah, that seems reasonable. And then the RIPE community was approached with a proposal to enforce hierarchical naming for new objects, and that worked out great. They implemented it in the span of a few weeks. Aaron has a mechanism called the ACSP process, where community members can make a suggestion for Aaron to do something. So since I already covered 2 out of 5, why don't you submit the form and...
I mean, Aaron, I take it. Afrinic, given recent developments, might be a bit more challenging, but...
We'll flip a coin on Afrinic.
Yeah. No, Aaron, challenge accepted. Yeah, I mean, it's a good thing. Let's do it.
Why I'm pointing this out, the only way we get the needle to move in any direction is to go to vendors. And sometimes that's me going to a transit provider, and sometimes that's you as transit provider going to an RAR. Thank you for the presentation.
Hi, I'm Alan Ising, a random person from the street, or Telia. I was wondering, you had a slide where you basically wrote that you wrote your own database to sort of mirror all of these various WHOIS databases and sources out there. Is this a good solution to recommend to people? Is there any other approaches?
We use IRRD, so we do not run our own software.
No, but you have your own database you aggregate into. The reason I'm asking is because if I'm doing an automation of a transit provider, I need all this information here, and it's vastly different how I access all of these WHOIS databases.
I think it's a scaling question, and depending on the size of the network. I remember in the very early days, like 10-ish years ago, we just pulled public data or public IR databases, ran into rate limits. That's one thing on their side, but also depending on the number of equipment, routers, systems you have internally. So I think that's something that really depends on what your network looks like. And and of course, long term, I think we should transition to other stuff than IR databases.
Jan Gronemann, also a random person off the street. I was looking at the presentation earlier. Why did you remove the cat?
Simple thing. I'm not the person for memes, and that's the main thing why I adopted slides, since they were not mine. So you have to have, the colleague of mine gave that at DKNOG as well. That's a presentation that you can watch the recording with a lot of memes. Maybe that's more fun, but not my style.
All right, thank you.
But it looks nicer, I think, now.
You mentioned that you were having issues with input validation and the difference between the at and the 2 colons. Can I set mine as close quote, semicolon, drop table roots, please? Do you have enough validation for that? And also 2-factor authentication?
I mean, when it comes to data input in PeeringDB, I think you can. I mean, we heard that earlier. PeeringDB is going to be behind two-factor authentication. I think there is validation by humans before you create objects in PeeringDB. I think that's yes. Honestly, I have not validated how the process of taking that data into, for example, IRD, how secure or how kind of good that checking works. That's maybe something that Job can take on for the next presentation.
Well, give Theo a big round of applause.
Thanks.
Thank you. And just before we start the quiz, we are just going to wait until you all filled out all the surveys for all the presentations. I think we are missing like 200 people on each or something like that. So, okay. But please fill out the surveys. Also remember to fill out the full conference survey. And so we can figure out what we need to ignore.
Here we go. So I also have a microphone while Fergus prepares everything else. I'm usually the one doing that, and this time I delegated. So,
in other words, he's still running Intel and doesn't have a decent battery life.
I'm poor. So we have a bunch of prizes. We have Swiss chocolate that I bought especially for this. We have licorice, and then we have T-shirts.
I mean, I don't.
Okay, cool. Who were gladly donated to us for the. You want to explain what the T-shirt is about?
No, it has an allergy, so we should leave it.
It has an allergy.
It has a dot.
Oh, I didn't see that. Okay, it has an allergy. Yes, you can be poisoned by this T-shirt. So let's prepare all of them here so you can see them. We have prepared, as usual, a nice quiz for all of you, and there are questions about every single presentation except the last one from Theo, because, well,
there's nothing on the screen.
Oh, it's coming. So while we fire up the part here, just get your app ready. As usual, we're doing Kahoot. So you can get the Kahoot app. And here we go. Yep. And you can click on Start here. Yeah, sure. Okay, so you're getting the pin. There you go. So
there will be no music, however, because music leads to dancing, and we know what dancing leads to.
So we have about, let's say, 60 people in the room. So we're expecting 70 to join. Because we know that some of you join twice to have more chances at winning, right? That's a good point. Yeah, you can do it with two phones. 3 computer and 2 phones. There you go. So you can make more mistakes. There you go. Mm-hmm. Okay, so we are up to
67.
67 people already. Wow, wow. Okay.
Next time we should use crack and it'll be even quicker.
So we have 18 questions. Some are easier, some are a little harder. Some just required you to be paying attention to the presentations. Of course.
Okay.
Sorry? What's that? Yeah, no, that's
okay, 20 seconds and then we're going to start.
Yep.
So if you want to sign in.
In the meantime, let's turn this off. There we go. So we don't don't need that.
Okay, we've been at 72 for a bit, so...
Yep, let's go. So, let's start with the first question. Okay.
Just to make sure you're at the right quiz, DKNOG15.
Okay, so why don't people implement 802.11x network authentication according to Julia?
They're not paranoid enough.
It's too hard.
They don't know what that is.
Or they already have WPA, as someone claimed. Do-do. 1 second still. There you go.
You see, they do pay attention.
This was to get warmed up a bit.
So,
Okay.
KLH.
Who's KLH? Oh,
Congratulations.
And Marco?
But you've got people 2 points behind you.
There you go. So let's see the next one. What is the lead time on a generator trailer in the UK right now? This is from yesterday's presentation, well, the keynote.
So, 90 weeks, 90 months, 90 days, or 90 minutes?
Well, some places might have 90 minutes. You never know.
You know, HHS Hire, you know, they're famous for being quick.
Are they being randomized, like the questions?
We'll find out. That's the next one. So.
No, because the questions are randomized, like I've seen, like the...
So Nicholas at 1913, then Mikkel.
Okay, let's see this one. Oh, this is a multi-select. What should you do with bosses who discriminate against women?
Refuse them.
Have them talk to Thomas.
Hug them.
Discriminate against them.
People are answering a lot slower on this one.
Well done. Well done. So have them talk to Thomas, especially if you're up for it. Oh wow, there's been a change.
No, Nicholas was lead on the last one. Theo's doing well though.
Okay, see the next one. How's the methodology built by Sinja and Sophie Colt?
Follow the data, follow the date, follow the fiber, or follow the money.
I have the impression these are not being randomized as...
Well, it'll at least give them like a timeline of memory.
No, yeah. Can you maybe check here if we can go...
Nicholas is holding his lead. Theo is keeping up with him.
Okay, so let's look at the next one. What kind of networks is RouteViews going to stop peering with? Hobby networks, access networks, or transit networks?
Two more answers needed.
I see. I put that in there just because of this. So it's hobby networks they're stopping peering with. Good, good.
Nicholas is doing what? Keeping up? Theo, we're a bit disappointed you weren't paying attention.
What T-shirt was Peter Lundqvist wearing? Sorry for the pronunciation. Was it Run UDP, Run DNS, Run AI, Run BGP? Let's see, still 4 seconds for a few answers still missing.
Two answers missing. Run
There you
BGP, most people got that right.
Well done. Who said Run UDP?
Two people did.
Two people, like even two Run UDP. Oh boy. Okay.
Nicholas is
still
keeping
on
it
top.
up.
Good, good. So, what's the next one? What color scheme did Job's slides have? This is a very tricky one. Was it green on blue, black on white, a very, very famous pink on violet, or was it white on black? So Job, you have to come up with your own color scheme, though, at one point. To come, yeah. Ooh. Sorry? Really? Sorry? It was white on black, no?
Well, it varied. Some of it was black
Oh,
and white.
little Bobby tables.
Oh, let's guess who that might be.
Okay. Good, good. Alan is on top as well. Yeah. So this is another multi-select. How big is the cooler in the FlexOptic slab setup? Is it lots of cooling, big, enormous, or bigger?
And don't ask me, because I have no idea.
Where's Thomas?
They left already.
They left. Oh. It was all of them. It was just all of them, just big. Oh, who's Ash? Ah,
Congratulations.
congratulations. Well, let's hope you can keep up here.
Alan seems to be doing quite well, but you know, you're dropping, mate.
What does ASPA stand for? Job, you can't miss this one.
Autonomous System Provided Authorization. Autonomous System Provided Authorization. Advanced System for Protocol Authority. Autonomous Soundproof Augmentation.
You got it right?
all, you know, but they still have to learn to spell authorization. That's an IETF problem, I think.
That's different stuff. Okay.
So no change at the top.
No big changes. What color was the car on Kent's slides? There were some slides with a car.
Red, blue, yellow, rainbow.
Actually, I did set it up differently in the original ones, and yep. It was a yellow car in the slides.
Oh, yeah. WW's up, moved up once.
So we have multiple instances of little Bobby tables. Eh? Okay.
So you drop table.
Whose repository has never had errors or issues?
Max, Randy Bush, Bob, or Joe. Alice wasn't allowed to play in this one.
Yeah, but let's consider it a repository, because also would have become a longer question. But good to see. Well,
most people were paying attention.
Someone was.
Everybody who got it wrong, please come and talk to us later for your homework. WW still up the top.
Cool. Good, good. What did Royce produce at the beginning when they started?
When he started.
When he started, yeah.
Cranes, cars, networking devices, or software.
Software. Oh.
Good. Most people were paying attention.
So,
Imperva will be happy.
Networking devices, really? Software? Really? One person? Really? Okay, cars I can understand, because I actually even got it wrong when I wrote the question.
He did.
He
had trains. I don't remember trains in the talk.
Look, I'm not a native speaker. Trains, cranes, I was not really fully paying attention.
I rest my case.
It is what it is.
So no changes at the top. WW is pulling ahead though.
There you go. How long is the wait for the connection of solar parks into the grid in the UK?
5 years until the UK rejoins the EU. 1 year or 2 weeks.
It's up to you. It depends if you want to win something or not.
Five years? Yeah, most people got that right. 1 year, please. This is Britain.
And there are three people until we chose blue.
Just look, okay, because we have fantasists in the room doesn't mean we should ridicule them publicly.
That's fine. That's fine. It could be in 5 years. True. So we have to withhold all the prizes, and especially the chocolate. We can. Yeah, that's good.
So still no changes really at the front. Third and fourth, though, are starting to catch up a little bit.
Okay, what company presented about segment routing for a change?
Hey, at least it wasn't SRv6. Compaq, Cisco, Juniper, Arista.
This is easy. Is this easy? Let's see.
Cisco, apparently.
And still we had a red one. Still. Compaq. Was it you? No? Okay.
And
so
still no changes.
they're stable. And which question was this? What number? 14. So we have, okay, 15th now.
What is ARP replaced with?
In IPv6.
IPv6 RD, IPv6 ND, ICMP v6, or IPv6 ICMP? No, there is only one choice.
That's true, but that can be true, yes. No, well, ICMPv6 we can argue, but it's like the neighbor discovery dance that I would consider as. Okay, so things are stable on top here. Okay, so let's see if the last three questions change something. In which OS did traceroute first appear?
4.4 BSD, Slackware Linux, Windows 95, guitar sound, 4.3 BSD Tahoe.
Yeah, it was.
Pretty sure the right answer is on this slide because we copied it. That's not what Theo told. No, it's Tahoe.
It was. I think it was Tahoe.
On that side there was one thing. On that side Oh, changes. Julia, we're disappointed.
Okay.
If it's not on the slide deck, it can't be the right answer.
You go to Reno, and then you go to Tahoe. So sorry about that.
Welcome to the new world of DKNOG.
Okay, sorry about that.
So, the important thing is that our leader is still leading comfortably.
How many new features were highlighted by Paul for PeeringDB?
3, 4, yes, or 9.
And Paul has left, no?
Yep.
Oh. So we can't get the real facts then. You'll have to trust what we put in here. It was 4. At least I saw 4 different points he was mentioning. Ooh.
Oh, Julia's caught up again. Well done.
So this is the...
And she's actually caught up close enough to be able to take over WW.
Yes. So this is the last question, right? Okay.
And Lasser's like appeared from nowhere. Does it? Oh, okay. So we don't have to worry about you having a back login. Okay, that's important. So,
Okay. Which probe was showing the issue first in Julian's presentation? There was one probe that was pointed to.
all of them? Number 7 and 9, number 4, or number 5?
It was number 5. It was right in the middle of the slide.
Everyone guessed.
I know. It could potentially was a guess.
So third, ESH.
Who's ESH?
Congratulations.
Second is WW. And then first, our winner is, Julia.
So who's WW?
So, Julia, you can choose the shirts, Swiss chocolate, licorice.
I thought we did shirts like first and second, or because then we're not fit everything.
Yeah.
So choose your candy.
I'm honored that you think I fit that.
Yeah,
Yes,
that's true.
So
That's true.
Choose your candy of choice.
I'm going to go with chocolate.
Cool.
Swiss chocolate.
Okay. Come over on stage.
And WW?
The shirt.
Do you have a medium?
No, the sizes have been cut out. We absolutely.
Well, check it.
But you still you get to choose.
Yeah, should be good. Yeah.
Okay.
Cool.
And the
I get to
licorice.
choose down as well?
Yeah.
Cheers. Thanks.
Come here on stage. Come here on stage.
We get to embarrass you more in return for the prize.
Do you fit in the shirt?
I'll try.
You'll try. Okay, and then come on stage because we can take a picture with all the winners.
If we had somebody with a camera. Does anybody have a camera?
Okay, there we go.
Thank you.
Congratulations.
Thank you everyone for playing. See you next year, hopefully. So, Lasse, are you coming on to say goodbye and...
Thank you. Let's have another round of applause for the quiz masters. But don't sit down too quickly, because as always, I'm going to have the program committee stand up here, because obviously I think it was hard to beat last year and even the year before that, but I think this year was, in my opinion, the most interesting and excellent program that we have had for DKNOG as far as I remember. So, this is the program committee, please. We can certainly ask Alan, Mikkel, Max, and Fergus. Please give them a very, very big round of applause. Fergus, thank you very much. Yeah. Yeah. Yes. Thank you. Thank you. And thank you very much for all your hard work in getting us all of these talks.
Remember to raise.
Yes, so
Two things. Remember to rate the talks. We will be very happy if you do so. We will be looking for more members to staff for our program committee. It would be very nice if somebody wanted to join us, especially, or you don't have to be local. It would be nice to have some more local people in Copenhagen, in Denmark, in sort of the region. I live in Norway now, so I don't even count as local anymore. So we are looking for new people, and please send us an email, pc or program@dknog.dk. Thank you.
We only have one local person on the PC, to put it into context. I mean, it's a great PC to be on because although there's only 4 of us, it's a really tight, easy to work with group. And we do everything in 2 months. It's not like a long-term all-year commitment. You know, it's relatively intense for those 2 months, but still it's only an hour a week. So please consider joining.
Thank you very much to the program committee, and please help them out because they're doing an awesome job. Thank you. So that concludes this year's DKNOG. I see that most of you are not here anymore. But those of you who are still here, thank you for sticking it out to the very end. Please consider joining our association. You have the QR code up there. If you are not already signed up as a member during your sign up for for the event, that's the whole thing. As a member of the organization, you get to influence what we do. Of course, we do this every year, but we are trying to do more. We have our mentorship program, for example. We want to do more kind of activities for supporting this community and especially the Danish community. And also, as you become a member, please consider joining the general meeting. This is where you get to elect the board members, me, and the other board members who should be in charge of running the organization. This is where you get to give your input. What should this organization be doing? Should it do more in terms of, should we have 2 events per year? Should we have an event in Jylland? We need volunteers actually to do all of this work. So one way of volunteering is to show up at the general meeting. You can also just email us with your suggestions or your comments. And of course, remember to fill out the surveys. The program committee really wants your input on all of the talks. The organizing team would also really want your input on the general experience of the survey. Please, if we haven't asked specifically, there are lots of open comment fields, so put in your free text comments. We read all of them, and we try to accommodate as much as possible what you suggest. And then, of course, as I mentioned, we have our mentorship program. We've advertised this last year as well, and it keeps running. Valeria is doing a very good job of organizing it. It is basically, if you're an industry veteran, you can pass on some of your industry knowledge on how to do, how to deal with difficult bosses, how to work in an ISP environment or something like that. And if you're new to the industry, then you can get someone mentoring you to teach you some of these things. I encourage you to sign up. It's actually really, really fruitful to have someone at a different level of experience from you to discuss with. And even mentors can learn a lot from their mentees. Other than that, thank you for this year. Next year will be same time, same place. Please remember to sign up. It's March 5th and March 6th next year, so I hope to see you again. The website is actually already up, although not accepting registrations just yet. But DKNOG15, please come back. Thank you.